I'm going to talk to you about design thinking and give you some examples of how that's deployed. I'm going to be talking about the early stages of product development. So let's start with that. So greetings from Leeds. Leeds is in the UK. You can see here, here we are in the centre of Great Britain. So we're right at the centre of Great Britain. I actually live in York, which is just up the road from Leeds, if you can see my pointer there. So I've come not just for this meeting, but for other meetings in Ghana. So I'm really, as I say, pleased to be with you. This is a very quick biography. So my field is more recently medical technology, med-tech. So things that are done by biomedical engineers. So that's where I sit, and I will give you some examples which may be in med-tech, which is harking back to my base, but it's equally applicable to other developments, product developments. So I have a PhD in pharmacology way back. I have an MDA from Warwick Business School, and most of my career has been industry. So at the moment I straddle both industry and academia. I've worked for big companies. So you can see on my slide I've worked for Pfizer, 3M, Smith & Nephew, medical devices, medical technology. And in recent times I've founded this company here, Neotherix. So Neotherix is a spin-out company from Smith & Nephew. We founded it in 2007. And it is still developing new med tech. But I've also have a foot in academia, so I work for the university for 50% of my time. I've done various jobs. Right now, I'm associate professor in engineering management and innovation. I'm also a mentor for innovation in LMIC countries. So you can see at the bottom of my slide here, I am quite familiar with being the only white face in the audience. So this is good, and I'm very much enjoying that situation. So I'm going to be talking about design thinking. I'm going to be talking about the scheme of TRLs, technology readiness levels, just as a way of managing your product development. So really what I'm focusing on here is the early stages of this TRL. As you can see, this TRL 1 and 2 is classified as ideas, needs identification and knowledge creation. So I'm going to be talking mostly at that end of the scale and working with you on that. And that moves into solution development, TRL 2, 3, and so on. Let's look at the definition, I like at least, of innovation. So innovation is executing an idea which addresses a specific challenge and achieves value for both the company and the customer. And each of those words really are important. You have to have the idea. You have to execute the idea that is important to your customer, is important to your company. Has to have value. So the customer values it sufficiently to purchase it. Has to have value. Has to have a value that they value. They value what you're producing because it allows them to meet a particular challenge, do a job that they want to do. And the value it would achieve for your company, of course, is that you have a transaction, you receive funds in exchange for your service or your product. So it has to do all those things. I talk quite a lot in my teaching about technology push and customer pull. So technology push has a place, but beware of having a technology that you're trying to push into a market that may not be what the customer is seeking. Look for understanding that customer, look to see how you can make sure that there is customer pull. And I give a couple of examples here. Technology push can work, and the post-it note, the 3M post-it note is one example of how that worked. An accidental discovery, accidental adhesive, but the inventors worked very hard to try and work out what the usefulness would be of this adhesive, this repositionable adhesive in the market, and it's generated over 4,000 products for 3M. So a successful technology push. But I've also put on my slide, why did this thing called a Sinclair C5, and this is the example that we use. Sinclair C5 was a 1980s electric vehicle. It was way ahead of its time, and it missed a number of important needs of the customer. So you can see on the slide here, it's a very small tricycle electric vehicle. Marketed in Britain. It rains a lot in Britain, so you can see there's no protection for this gentleman riding this C5. He's unprotected from the traffic. It's a dangerous vehicle. It did not sell. Sold about 4,000 units. Excellent idea. Wrong time, excellent idea, but they did not understand the market or the customer needs. So technology push can be a dangerous thing. So beware of enthusiasm for your technology that you're pushing beyond what the customer is seeking. Remember, Paul, though, can concentrate on the customer needs, but still miss the point. So you may know this quote. It's not going to play. No. Okay, so you may know this quote from Henry Ford, who said, or supposed to have said, he didn't really say this, but he was supposed to have said, if I had asked people what they wanted, they would have said faster horses. And because that's all they knew, they didn't know they could have a motor vehicle to drive around the streets. They just knew their current mode of transportation was slow and inconvenient. They wanted faster horses. They would say they would want faster horses. So you can ask people what they want, and they won't give you that answer because they don't know what is possible. You still have to ask them, but you have to add more. Steve Jobs was said, it's hard to design products by focus groups. A lot of times people don't know what they want until you show it to them. So Steve Jobs would never be able to sit people in a focus group and they would come up with an iPhone. It just wouldn't happen. They needed to be led through what was possible, what the next stages were. So it would have to be an iterative process. So customer pull is extremely valuable, but it's a hard thing to get right. So I'm going to talk about design thinking. Design thinking is really a set of tools. It's a approach which we classify as human-centered design, so putting the customer at the focus, as the focus or the center of your thinking. It addresses what we call wicked problems, what are called wicked problems. These are not evil problems, these are just difficult to solve problems. So they're messy, they're ill-defined, they're difficult to identify. There are many parts to them. Solving one part may produce a problem somewhere else in the system. The end point may not be clear, the means to the end may also not be clear. So they're really challenging problems. We teach in our course, there's a progression from creative thinking in the 1950s, a thing called design science, 60s, user-centered design in the 70s and 80s and so on, arriving at design thinking in the 2000s, the noughties and the 2010s. There's common methodology, nevertheless, in these approaches. They tend to use things like brainstorming and other idea generation methods. So just talk about brainstorming, and you'll be familiar with brainstorming, but just to remind you, this is it's done properly, is a formal process, a structured process, many stages to it, and many correct ways of doing it. But it is a group activity, and it's a group activity by which your group collects ideas and refines those ideas and goes forward with a set of ideas that they want to test further. So I mentioned there's a set of rules. So the rules of brainstorming would be things like deferring judgment, encouraging wild ideas, do not count ideas out at this early stage. Build on those ideas. Make sure that you stay focused on the topic. If you get ideas which are off topic, don't discount them, write them down, note them, but come back later to them. Don't talk over each other, one conversation at a time. Be visual, sketch it out if you don't want to give it a name, and you're aiming for quality. But there are rules, and generate those ideas and work with those ideas. I mentioned just now there's a progression of user-centered, human-centered design to get to design thinking. So just very briefly, user-centered design is the putting a product in front of people, collecting feedback and redesigning. Very important to do that, but we can go further. So user-centered design then is user-led design. User-centered design is a process of tools that are used to design and develop a product or service, and that focuses on what the user needs. And remember, the user may not know what they need, but they know that they have a job, a problem to solve. But continue with that focus of the user. And then human-centered design takes it a bit further. It looks to put that user, that customer, right at the center in the context in which they use the product or service. Okay, remember what Steve Jobs said, it's hard to do that by focus groups, you need more. You might want to use specialist tools as you develop your offerings, such as QFD and so on, but I'm not talking about the specialist tools today, I'm talking about the generalist tools of the design thinking, what we call design thinking toolkit. So there's a number of methods, processes, practices that you will need to use in design thinking. The origins really, as I say, go back to the 2000s or 1990s. Design thinking really is identified with the company IDEO. IDEO from the Silicon Valley. IDEO, whose original base was in Palo Alto in Silicon Valley. Originators also came out from the University of Stanford Design School. And what we have in IDEO is a way of, a philosophy of collecting those ideas, working on those ideas, making sure, again, your customer is central to all that you're doing. So my slide just shows you a few things about IDEO. I had the privilege of visiting IDEO in around about 2005 and just seeing things at their base and how things were done. And it was really eye-opening to be there. The IDEO people that originated this process of makeathons, which became hackathons. So you're familiar, obviously, with the hackathon. So it's going back right to that base in the late 90s, early 2000s at IDEO. So what do we see when we look at that process? Well, we see three I's. So the IDEO process is these three I's: inspiration, ideation, and implementation. So a process, a pathway to your product, a process, a set of tools, and a mindset. Underneath those three I's are the 5 steps. So I'm really focusing on the beginning today. So empathy, your customer again. Put yourself in the customer's shoes. What do they do? What are their frustrations? What are their frustrations? What works for them? What doesn't work? And then move to define, and then move to ideate your solution. And you're prototyping, you're testing that solution, eventually testing and further testing before you deploy that, what we trust will be a successful product. It's not a linear process. You'll need to spend more time in some of these than in others, depending on your application and the challenge and the degree of difficulty. But the principles hold firm. And there are many tools in this toolkit, and I'm not time to talk about those tools this morning, but you can see on my slide beneath those 5 steps, there are a number of processes that can be deployed. You don't have to deploy all of those, but select those which are most effective for you under empathy and define and ideate and so on. IDEO also, just to add to this richness, talk about 7 innovation attributes. And I think we heard yesterday about failing early. It's important to do that. If it doesn't work, we need to know it's not going to work and put that idea to the side and start again, start with something else. Interviews, understanding the users, but the full spectrum of users, not just your what you think of your primary customer, but those associated with it. Focus groups do have a place, no question. Okay, but also think about those other things. Make it if you can. Early prototyping helps you to conceptualize it. Be optimistic. You can solve this problem. There is a solution. Iterate. Use divergent thinking and convergent thinking at all stages. So as many ideas as possible, collect as many ideas as possible, and then select down, filter those ideas, select them down. When your divergent ideas are collected, suspend judgment. Don't squash an idea because you don't think it fits, but just keep it there. You'll have a chance to do the filtering and the analysis. So divergent, create choices. Convergent, make choices. Make sure you understand exactly what that customer needs, not just a simple need, but think about their overall behaviors. How will they interact with this product? Will it make a difference to the way they live? Will it make a difference to other products they use? All those things are important here. So repeat those cycles of convergence and divergence, convergence. And just to give you another example, this is the model of Wheelwright and Clark, the innovation funnel. So getting, again, as many ideas as possible, but you can see in their model there are a number of screens, 2 screens here, by which they can filter these ideas and select the most promising, but build on those ideas, expand them again, and finally put them through another screen. And it's not restricted to these 2 screens on this model, but use as many as you need to use. Okay, so to bring this to a close, our course at Leeds talks about changing the mindset on what the word design means. So on the right of my slide here is a number of things which I'm not talking about today, but you need to think about the kind of team you need. You need to think about the level of innovation. Is it radical? Is it adjacent? Is it incremental? Which will affect the resource that you need to bring that to fruition. And the approach, how much is known about your idea and your technology. But overlay design thinking on all those other aspects of product development. Okay, so your task, ladies and gentlemen, is to apply those things in your teams, your groups, your hackathons. Deploy those, apply those. And remember to start with the understanding that the problem that the customer needs to solve. So that again, focus on the problem and make sure you understand the problem that the customer needs to solve. And don't just think that the customer is your user. And I've gone back to medical tech here. It's not just the patient, but it might be the doctor who's using it or using it with the patient or healthcare professional. It might be the hospital. have they got the resources? Have they got the infrastructure to use the product? Might be the budget holder. Can they afford your product? Might be fantastic, but it may cost too much. What about the government? Are they going to license it? So think about all those customers as you approach and develop your great ideas into great products. Okay, that's that for today. Thank you very much.
Thank you very much. So we wouldn't take questions for now. We would give our second presenter the opportunity to present, after which we would have our question session. But I believe we were already learning so much from the first part about design thinking. And we learned that you have to understand the problem to be able to provide a good solution. So now we continue with understanding today's theme, Designing Tomorrow, the product development cycle, with the next presentation on iterative prototyping and user feedback. So to help us do that, let's welcome Nana Osei Brown from Engine to present on this topic. Please let's welcome him with a round of applause.
Good morning, guys. Good morning. You didn't eat breakfast. So while he sets up, just want to quickly introduce myself. My name is Nana Osei Brown. I work with Engine in the innovation and automation space. So I've been running the team there for about 1.5 years now. And what we do is essentially take on projects to build AI-powered solutions using different development tools, either low-code, no-code, or native code. So that's who I am, and I'm here to speak to you today about iterative prototyping and user feedback. In the presentation, I'll give you a quick introduction, call out the benefits of developing software this way, talk a little bit about how we actually implement this in our software development process, a few pitfalls that I've experienced, and just a light use case walkthrough before I conclude. All right, so what is iterative prototyping? Hands up if you spent any time in the kitchen watching someone cooking yourself. And you guys don't cook. Yeah, so have you guys noticed that when people are cooking, like you're making a stew or a soup, after they put in a little bit of salt, the first thing they do is taste it and say, okay, did I put enough? Did I put too much? If they put in too much, then they pour in some water. If they put in too much, if they put in too little, then they add some more. And then they stir it. Then when they add pepper, they check, is it too much or too little? If they need to correct it, then they do. That's essentially what iterative prototyping is the idea or the concept of tasting while you cook to ensure that what you end up with is exactly what you're expecting, right? So how does this apply to software development? It essentially means that as you're building your software, whenever you build a new feature or you make a significant step, you need to stop and have your user comment and tell you, okay, this is exactly what I'm expecting to see, or you're actually way off the mark. So I need you to go back and rework this design or make a few adjustments. So that's essentially what iterative prototyping and user feedback is. It's the process of creating, refining, and testing your product as you go along. So what are the benefits of building software this way? The first and most important is you get to identify issues and errors way before it's too late, right? So if you're building a software and you make one mistake, but you don't correct it, it compounds. So by the time you put out a solution, it has a critical error in it, something that will take even more time and more money to fix, right? So the second benefit here is you optimize your development cost and time. If this product would have taken you 6 weeks to ship, or to deploy or get to your customer. Because of this big mistake, it might take you 2 weeks to go back and correct it. So now it's taking you 8 weeks and 8 weeks of cost to actually build this product. That would essentially have taken you 6 weeks. Whereas whenever you make an update or a feature change, you sit with your user and you ask them, what do you think about this? And they're like, this is exactly what I want, or this isn't what I want. Once you get that feedback, it allows you to develop quicker and develop right. You don't want to get to the end of the road and find out you made a critical error somewhere in week 2, right? So that's one of the big benefits here. And lastly, you ensure product quality and user satisfaction. The user being the key aspect here, right? Because you're not building for yourself, you're building for someone. So if they are not happy about what you're giving them, or they don't get what they expect to get, then you've actually failed. Right? You can build the greatest thing, but if no one wants it, then you failed. Right? So you need to be able to get your user involved in your development process. And this is a key aspect of building software this way. All right, so how do we actually implement it? This process just shows how we have implemented it in the past and how we recommend teams develop software. First, I give you the process, and below I add a few tools or methods that I have used in this process for each stage to help me accomplish it, right? So first, and this is a common one, or a very important one actually, being able to define the problem and the goals of your project. So what is the problem you are trying to solve? Who are you solving it for? What does the solution look like? And what are the features of the solution? You have to clearly call all of these things out. I prefer using documentation. I think well-written documentation is one of the key aspects of any software development process. So sitting with your stakeholders in a room, having a workshop, and being able to call out, this is exactly the problem I'm trying to solve. People are hungry, I want to feed them. How am I going to do this? I'm going to give them food. Step 1, I'm going to clear an area and plant cassava, whatever it is. But being able to clearly call out the problem you're trying to solve and how you intend to solve it. That's one of the key aspects. Once that's done, either through documentation, by drawing it, by having a recording, however you want to document this process, the next thing will be to create a rough prototype. And I use the word rough there just to call out the fact that it doesn't have to be perfect or final. If someone needs to know how to do something, it could be an aspect of design. You want to see how this solution will look like in real life. Or you want to actually see if it's possible, if this will work. If someone comes to you with a very innovative and crazy idea, you need to do a feasibility analysis. Is this something that can actually be developed, right? And in that rough prototype phase, you confirm that your solution is feasible or it can be done. And if it's going to be done, what would that look like, right, for a user's perspective? So for that particular phase, we emphasize speed over looking pretty, if you want to call it that, right? So for that prototype phase, you just want to be able to identify the key features you are going to develop and what they will look like for the end user. So using design tools or no-code, low-code platforms, I think is the best way to do it because you can move very quickly without little to no interference. You don't need to do any environment setup, any deployment issues. You can quickly build and quickly present this to your client, customer, focus group, whoever the client may be, who the who is, if you want to say that. And once you build this rough prototype, the next step would be to obtain feedback from users. So either a live demo, you sit with them and show them what you built. So these are the requirements you gave me. This is the prototype I've put together. What do you think? Right? And they could tell you this is exactly what I wanted. But half the time, the client doesn't even know what they want. So when you show them, they're like, I actually envisioned it looking like this, or the other guy's one doesn't look like that. Why does mine look like this? So you need to actually sit with them and let them point out, okay, this is where an error is. I need you to fix it. And that's the beauty of this process, right? So you don't need to go very far. You can move from step 1 to step 2 in a few days and get the feedback very quickly. If you had gone all the way to build a solution and taken 6 weeks and they tell you this is actually not what I want, it's wasted time. Right? So getting their feedback is paramount to building a good product. So this process, as you can see, is iterative. So you go back and forth with the user on this. You can go build something and they're like, this is not what I want. Then you have to go back to your drawing board and build again. Or they can say, this is perfect. Then you move to the next feature. So this process tends to be very iterative and you spend most of your time in that phase. But once you are done there, you know everything else is smooth sailing because you have your documentation, you have your prototype, you know, you have a map essentially of what you want to build, and how you want to build it. So developing the approved prototype becomes fairly easy, right, and straightforward. So you're just following a map that has been drawn out for you. Then you can develop your process. And for this, you can use whatever tool, whatever development tool you find helpful, native code, low code, however you want to build your software, right? So that's basically how you would implement iterative or include iterative prototyping and user feedback in your software development lifecycle. So a few pitfalls to avoid in this process is the lack of clear objectives. You can actually put together a document that doesn't say anything. Someone says he wants a waterfall, everything he wants a waterfall. There's no actual detail as to what he wants. So for this document to be helpful, it needs to be super detailed. You need to be able to call out stepwise what exactly the user is looking for, what exactly you want to put together. So this generally occurs when you have inadequate documentation, or you haven't taken enough time to listen to your client, ask the right questions, gather the necessary feedback. Right? So once you're able to get all of that sorted and you have good, clear objectives in your documentation, that's a very good one. That stops you from having errors down the road. And secondly, not involving the end user in the process. Right? You can be building something for yourself, but no one has any interest in it, right? So being able to have the user involved in the process, well, this is exactly what the documentation says. Have a read, let me know what you think. Do I accurately capture what exactly you're looking for? And they can tell you, yes, perfect, or no, that's not what it is, right? And even after they've told you that you've captured everything, you could go on to your prototyping phase and build something and think, well, they already agreed to it in the documentation, so let me just go ahead and build a full thing. And then when you show them, they're like, yeah, no, this is not how I envisioned it. So you have to really keep your user involved throughout the process, through the documentation process, through prototypes, so they can see exactly what they expect to receive, and let them approve this before you go ahead. Right? So once you're able to avoid these common pitfalls, I think implementing the process should be fairly simple, fairly straightforward. All right, so I'm going to do a quick use case walkthrough, a personalized chatbot. So a client came to us and said, well, this is our problem. We have an issue. We have too many documents, right? We have a lot of customer service departments, and whenever they have to respond to a customer query, they have to go and read through about 10 to 20 pages of documentation just looking for one line to confirm the answer they need to send to the client. So what we want is simply a chatbot that has been fed with these 1,000+ documents that we can quickly query and get the answer we're looking for, and have the user couch that in the way he wants to and send it to the client, right? So this particular use case, we did a quick workshop with the client, asking them the key features they are looking for in their solution, what exactly they want to see, and how they want it implemented. Following our process, we had to define the problem and the goals. We had a lot of documentations. The one I'm putting here right now essentially are the user stories that came out of those documentations. So as a user, I want to be able to upload documents to a chatbot that it can reference them when answering my questions. I want to be able to ask a chatbot questions and get answers based on the documents I've uploaded. And lastly, I want to see the exact document the chatbot is referencing in case I want to send this document along with my response, so I want to validate the response myself, right? So these are some of the user stories that would come out of such a session or came out of our session. And then from those user stories, we created a rough prototype, right? The tools I use are UiPath and something called an AI sandbox. That's a proprietary tool that we developed that allows us to expose AI models onto automation platforms, because we felt like automation platforms and low-code, no-code platforms are very good for prototyping. But we have this issue of getting models onto them very quickly. It takes very long, so it makes the prototyping period seem like you're developing the whole tool or a whole application. So using our own tool, using our own people, we developed this tool that allows us to quickly deploy onto these automation platforms and allows us to prototype even quicker. Right? So using this combination of tools, the features I decided to prototype were the document upload, the question answering, and the response reference. And this was the demo that we showed to the client, right? So let me see if I can play it. So what we see here now is, oh wow, it's not very clear, is UiPath. It's a low-code, no-code platform. And what it's going to showcase here is the ability to select a document to upload be able to ask necessary questions from it and get a response as well as a reference. Essentially, the features I told the client will be able to prototype. So let's see how that looks. So here I'm selecting the hackathon document. I'm sure you guys can't really see properly, right? No. But let me just describe what's going on. So here we're just asking the chatbot, hello, getting a response, hi, how can I help you? And then asking it, can you tell me a little bit about the hackathon? Essentially the document I've already uploaded into the system. And, excuse my typing. And it was supposed to give me a response from the document that I had just uploaded. So this actually goes into the document I uploaded, extracting the text and telling me, okay, you're looking for information about the hackathon. Let me summarize that and give it to you. And that's exactly what we saw here. So now I'm asking another question with regards to the prizes that the hackathon offers or provides. I don't know. So here it gives me my response and even references the exact page of the document they got the answer from. So showing this to a client and saying, these are the features you wanted, the ability to upload a document, ability to query it, and ability to get a response with a reference. So showing this to the client, he's like, okay, it's exactly what I want. Now, what about the UI? What about this? What about this? And I'm like, we'll get to that. We just wanted to ensure that the key functionalities or the key features of your product have been met. Right? So based on the feedback we got from this prototype, then we moved on to actually build a solution around it. So what would that look like? Right, so here's the actual solution that was delivered to the client. It's essentially a chatbot, but it's been preloaded. It's been preloaded with about all 1,000 documents that they initially requested for, and that was done on the admin side, so you probably won't see that here. But here, just being able to ask the chatbot a question, get a response, as well as a link to the document that the response came from. That's what we're going to see here now. So I just asked the chatbot what kind of questions I can ask it, right? And it basically gives me a list of topics that it's been fed on that I can request the information on. So I went on to ask about. So because it was a health company, all the documents had to do with health regulation, COVID procedures, and other health and safety documentation. So I went to ask about what some of the procedures that would help someone prevent exposure to COVID. And now it tells me that this document actually doesn't have specific information on COVID because doesn't have information on COVID specifically, but has information on other types of procedures. Would I want to know about it? And I'm like, yes, give me the information. And once the information was given to me, I was able to reference the document that the information came from. Apologies, is actually a German document because the client was German, but this essentially showcases to the client that, well, this was the prototype you asked for, now here's the solution based off of that prototype. So to conclude, iterative prototyping is just the concept of tasting while you're cooking to ensure that your finished product is exactly what you're looking for, right? So it's very important that as you build your software, you make sure you're doing exactly what the client asks for and you keep them in the loop. Secondly, building software this way allows you to identify errors, saves time and cost, ensuring that your product is of good quality and actually meets the needs of the user. Largely, things to avoid are vague objectives. So someone saying, I want something without giving detail as to how exactly they want it. and user exclusion, keeping the user out of the loop, assuming you know everything and going to build what you think you want, right, and submitting that to the client. Doing things like this will ensure that your product at the end is of high quality. Thank you for your time. I'm ready to take questions now.
Thank you very much. So I'll give a few of us the opportunity to ask questions based on the last two presentations, and then we have the next speaker come on board. So if you have a question, kindly give me a wave, and then you'd come and ask your question. Any question based on our last two? Please let's welcome him with a round of applause.
Yeah, all right, thank you. Let me add these two questions, one to each one of you. So, Prof, when it comes to design and thinking process, most of the engineers, sometimes we have good ideas, we put too much effort into our design and thinking process, but normally it comes to nothing. So what kind of advice would you give to these young engineers? And also to my friend, when it comes to modern software development, there are so many methods or so many models. Most people even prefer what we call the agile method, because they think that one is more flexible and also you can adapt at any point. Why do you settle on this one when you say iterative is the best, or if I put it that way, why do you settle on this one? All right, thank you very much.
Thank you for the question. Good question. We all get very attached to our ideas, and they become our pets, our babies, and we all do that. Well, that's why this principle of failing early, failing fast, is an important one to embed, and be prepared to have very clear objectives. My friend just mentioned those objectives. Very clear objectives, very clear criteria for pass or failure. You know, so using a different technique or process, that of stage gate management. Does it meet the criteria to pass that stage, pass that gate, to go to the next stage? If it doesn't, then you either have to go back to the stage, or you say, we're going to do something else. I like to say that in a big company, your team is pitching for investment just the same way that the hackathon people would pitch for an investor, because that company has £10,000 dollars to spend, and it could spend it on many other things. So is your idea the best application for that £1,000 dollars, 10,000 CDs, or whatever it is? So having very clear criteria, and being flexible enough to say, okay, there's plenty of other things we could do, or maybe we need to do some iteration and to build some new features into this. But yeah, just being able to what we call carry it with open hands, and say, okay, this is not what we want at the moment, but we could make it better, or there's actually other opportunities that we prefer to do. So having those objective criteria to test is really, really essential. Hope that helps.
So your question had to do with software development methodologies, right? Agile, waterfall, Kanban, etc. I think it really does come down to the team you're working with. So I found that with my team, Agile works very well, but also depend on the project. It's a very small project. Putting together an Agile team doesn't make a lot of sense. So sometimes we go waterfall. So it's really a combination of scenarios or situations. So for bigger projects with a bigger team, Agile helps you manage everything. Sometimes it's a small project with a smaller team. I prefer waterfall. But very much, a lot of these things depend on the team you're working with and the project you're working with. So you have to kind of consider that, right, before you select the methodology you go with. You shouldn't take a one-size-fits-all approach to software development. Thank you.
Okay, thank you very much. I'm sure we still have questions, but then we would save our questions till after our next presenter is done. I have exciting news for us. So Chango would be giving out free t-shirts to all those who subscribe to their page today. So after today's seminar, you can move down to the exhibition room. They will be there. Subscribe to their page, and then you are getting a free t-shirt. So now we move on to the next presentation, which is going to be on strategic decision-making in product development, balancing innovation and technical debt. And to help us on this topic is the software engineering manager for Nalo Solution, Mr. Alexander Adade. Please let's welcome him with a round of applause.
All right, good morning, everyone. Yeah, as you already know, I'm Alexander Adade from Nalo Solution. I've been managing software projects from 2016. So today I'm here with you to discuss about strategic decision-making in product development. And I believe most of you have already shipped your code. So assuming you're supposed to raise a PR for me to review your code right now, do you think it's going to pass? So let's look at it very, very well. We are going to start from balancing innovations with what technical depth. How are you able to do this if you start afresh? Or how are you going to do this if you already have an existing project that's ongoing? Or possibly, it could be that you're actually added to a team where you're supposed to work on set project where there is a massive technical depth and need to resolved. Okay? So let's look at how we can go about it. Yeah, so in tech world or in tech firms, what we normally do is that we find ways and means to drive innovation, irrespective of whatever happens, because the company is supposed to grow, right? What about in a situation where you have a lot of technical depth? So when you get to the technical depth aspect, we are going to examine it very critically to get to know how to resolve those things. But what do we mean by new features? The new features are actually what? The new ideas, the innovations that you want to actually thrive so far as the company is concerned. Then the technology, for instance, if you are building afresh, definitely you want to use the technology that will actually suit your situation or actually resolve your problem for you with ease, right? If you already have a already existing project that you are working on, the technology might probably be you wanted to build a data engineering pipeline that you are going to use to get insight into your product so that you can actually engineer the system in such a way that you have value for the service that you are running. Then the customer experience. So mostly, when we talk about customer experience over here, we are looking at how efficient is your product, how reliable is your product. Efficient measures what? Effectiveness. Then reliable actually look at how long is the product has been running and hasn't been any failures, right? So let's say if you deploy a system or an application and it has been running about maybe 99% with no failure, we say it's reliable, right? Normally you don't achieve 100%, but 99% is okay. But if frequently you send an email to your customers, my product is down, give us some time, we're going to fix it, and this kind of stuff, you get it, it's not reliable, okay? So how do we make sure your product is reliable? So these kind of things, we look at it very well, then we take it from there as well. Then let's look at technical depth. When we say technical depth, we are actually looking at it's essentially implied feature cost, right? That is required. You get it. When you do quick physics, you see, most of the times our PMs or our product and project managers, will be on us because a customer needs a fix. So we have to do it quickly so that you can go live, right? We normally call these things quick fixes, right? When you do that without taking a critical look at the problem and resolving it so that in the future, it won't come back attacking you or it won't come back affecting your product that you have built in the long term. You get it? We end up accumulating technical debt. A technical debt could be on your code base, right? If the code is poorly written, it's inefficient, right? No documentation, the design of the entire system is a whole of flaws, right? Can also cause a problem for you in the near future. Now, mostly if you find yourself in this situation where you need to drive innovations whilst you have a technical debt, how do you do that? It should be possible because the company wants to release a new feature whilst there's a problem on the code base. So how do we do that? We normally actually waive this. You should be able to waive this innovations through whilst you are fixing the technical problems. For instance, let's say there's a piece of code where you actually you have to work on it to resolve some of the technical issues or technical problems that your company is encountering. Whilst you are fixing the issue or whilst you are resolving the technical debt, you should be able to actually add the new features that will actually make the company thrive and get revenue at the end of the day. So normally you need to prioritize the two of them. There's no way you do one and leave the other one. You need to do the two at the same time. So it's possible to do that. Most often, as human as we are, we tend to be more of focusing on the short-term success. You know, most of us, as human as we have already mentioned, we look at getting more success as quickly as possible without actually looking at the long-term implications, right? Some of the things that you get instantly might not necessarily help you in the near future. So mostly, we are not saying you shouldn't go for the short-term success. We can go for them, but you need to also sit back and realize how it's going to impact my product in the near future. You get my point? So what you do is that after you've gained your success or if you attain your success, you sit down and you analyze and see this particular success should be a benefit to me in the near future. If not, you quickly do something just to make sure you are in line, not accumulating technical debt. All right, so let's look at how you can actually strategize to balance technical debt with innovation. Regular refactoring. Normally, when you're doing refactoring, you are not changing the function of the code or the actual behavior of the code, but rather you're changing the structure just to make sure you get optimization for high performance. So you can do refactoring as a means of managing your technical debt or a means of resolving technical debts. Because when you do that, normally you have better readability, you have better maintainability, and as well as the code quality also excels. So normally it's a good style to actually be refactoring. Then testing. You see, at the end of the day, you should have a code base, and that code base you have a test base as well. Without a test base, I don't think you have actually a product. Because at the end of the day, if you can't test what you've written, then it's zero, right? So the test, you should have a functional test, or the functional-based test, you have an integration-based test, you should have the regression test as well. So the function-based, you take the business rules within your code, then the integration test, you test the flows between your functions. So function A, function B. The output of function A should actually be tested while you're integrating toward the function B. So this ends up getting the better way of your testing. As well as the regression testing is when you put the changes, but does that particular change affect your existing product or your existing code base? If it does, then you have a regression testing. So you have to make sure you test your changes as well as integration into your existing product if it works for. Then customer feedback, right? You know, mostly when we build product, what we end up getting is that the customer will give us a feedback on what we built so far, whether it's a good product or it's not a good product. Most of the customers will be frank with you that, no, this particular product is not working for me. There are too much issues, too much problems that we need to resolve. Others will not say anything, they just move to another product. You get my point? So you have to make sure you have reliable customer feedback. But the question is, do you have to wait till you get the customer feedback? So that means you have to actually test your code. You have to actually have a measurable means of seeing what the customer will experience at their end, as well as you remove the bottlenecks or the issues that may be what incur as well. That improve documentation. You need to have a documentation that will address the issues, that will actually tell how the product actually works and how to use it. This documentation, from developer point of view, you have to actually have post-market documentation. You have to have a product description. We have to have something called tech discovery. So tech discovery is more or less like in details of your product that you are building, right? And other tech-related stuff you are going to use to build a system. So mostly, it's always advisable to have a tech discovery for a particular product that you are building, okay? Apart from what the business people will give it to you, is the product description, the tech discovery also serves as a good purpose when you are working with what? Product. Yeah, so how do you find this balance? Okay, as I already mentioned that to find the balance is very simple. You can't stop innovating, and you can't stop resolving or reducing technical debt. Technical debt is more or less like a financial debt. It accrued over time, right? So how do you make sure you don't accrue those interests of debt on your code base, right? So whilst you are innovating, whilst you are resolving the technical debt, you end up, or you agreed with your product or the stakeholders to waive in your innovations whilst you are resolving the technical debt. I think that would be all. Yeah.
Thank you very much. Please, you may have your seat up here. So this is the time for questions and answers. So if you have questions from all our 3 presentations so far, kindly walk up to me and then you can ask your questions. Questions. Please let's have questions because they've really given insightful presentations. And once you ask your question, you'll be able to get further understanding of what has been said so far. So please, if you have a question, feel free to come up here. I'll give you the microphone so you can ask your question. Okay, so I have someone coming to ask his question. Let's give him a round of applause as he comes to ask his question. Please, anyone else while he's coming up so that you follow? Amazing. So let's give her a round of applause as well. Okay.
Thank you very much for the presentation. It was very, very insightful. One very important takeaway I had from the first 2 were on iterative designing and human-centered design. But what I've come to notice over time working on various projects with my colleagues is that we often can't make a delicate balance between these 2, because we can sometimes finish with a project and then realize that it was too iterative to the extent that if we want to now look at a human-centered approach, we'd have to overhaul the entire designing process. And furthermore, on the documentation phase, I personally find it to be a very tedious task doing documentation. It's often more exciting during the project than the documentation, but we've come to understand that it's also a very important thing to also document. So would you advise that documentation starts early, even before, say, you've started iterative design, or maybe it comes later into the project after you're done with it? Thank you very much.
So I think my question is directed more towards Dr. Axworthy. You spoke about how technology push could be dangerous because oftentimes there could be no real markets for it, and at the same time, customers don't really know what they want until it's shown to them. So my question is there a way individual entrepreneurs are able to, or companies are able to assess the risk of acceptance and know whether to go forward with an idea or just to check it? Thank you.
Thank you very much. I think we would answer these two, and then if there are any more, we'll take it from there.
All right, so for the first question with regards to documentation, so I think we have this mentality that documentation is literally to write down what we did, but in design, it's meant to actually guide what you build. So you shouldn't finish developing and start trying to write down what you did, but rather write what you want to do and then build it. And that way, you are actually using the documentation phase to actually guide your development. And this makes it easy, first of all, to make sure that at the end you have practically completed documentation. And also you don't have that mismatch between what you wrote and what you actually did. So I think to answer your question, documentation should start before, and it should be the basis upon which you develop, and not the other way around. That's for the first question. And the second one had to do with balancing the user feedback and the iterative design. And I think these two go hand in hand. For on every phase of iteration, the user should be involved. So it's not you and your colleague going back and forth, oh, I think this is the best way to design, oh, this is actually better, we can do this, and then you start having a very technical discussion. But the idea is on every iteration, you involve your user and he tells you whether it's good or not. So if you keep him involved throughout the process, one of the major pitfalls I mentioned was not keeping the user involved. Because if he's involved, by the time you're done, you would have something that the user actually wants because it was part of the creation process. Thank you.
Okay, thank you very much.
Okay, so there's a couple of questions I have. One about human-centered design. Can that be too iterative, and how does one go back to an earlier stage? I would put the principle of the minimum viable product out there. So can you get to a point when you've achieved something with what you have, do everything you want to do, and it doesn't meet every need of the customer, but it might meet 75% of those needs, and it might have a place in the market. And of course, that doesn't mean that you stop there. You might stop there, but you have the opportunity to bring out the second generation, third or fourth generation of that product. So have in mind what the minimum viable product would look like. Have you achieved that? Can you go beyond that? But can you, I mean, you might just stop there. So that's one thing I would say on that. The other question on technology push being potentially dangerous, and I made that point. Yes, it can be, and we can get so tied up with the excitement of the technology that we miss really what the needs are. How do you assess that? Well, we just talked about involving the user, the iterative, the phased involvement of the user, and really bringing that person or those people or that group of people back at every stage is one safeguard against pushing the technology regardless. So I would say that is probably one way to keep things a bit safer. In our medical medtech development, we have a patient involvement group, PPI, public and patient involvement group, and we involve those people. Do they like what we've done at that stage? They might say yes, but, so we need to go and do something else or change it or take something away or balance another feature. Bringing out a feature that might be more important to that user group than something that we think is important. So just listening and testing and not just the focus group, but going beyond that focus group, but certainly taking back that information and reworking our product on the basis of that.
Thank you very much. I'll take the next set of questions if there are any.
Thank you very much. My question is particularly, let me try and explain it. So you kept on mentioning that project design with the project makers and then the customers should be iterative. So that means you move forward and back as you are moving from each step to another. And then you kept on, you also, Professor Roxworthy also made mention of patient and then maybe medical staff working with you, the project maker. I want to ask, does it sometimes, these iterative moments, make your project lateral in a sense that you may have a goal you are focused on, but maybe because some of the statements your patient or the medical staff may make whilst you are designing your product, it can skew you off your project pathway? And then how does it affect you as the project maker, your market, and then your relationship with the users as you are moving through each iterative method?
Thank you.
Thank you. Thank you. I'll try that question. One of the things that that I didn't mention with all the customers, the stakeholders, one of them is the funder, who has provided the money. I work with a lot of public grants, so they are providing the money, and they will want that project done as the application, and then it's very difficult to change it based on some new customer feedback. So it is a tension. We don't want to produce something that is not going to be of use to the customer, the patient, the user, but we have to get permission to change the project objectives and endpoints, milestones, and so on. So it can be a real tension, and it just illustrates that there are so many stakeholders involved in any product or any product development.
Okay, thank you very much. So we'll hold on to the next set of questions because we have 2 more presentations to go, and then we'll be done for this morning's session. Our next speaker is going to be speaking on AI and machine learning, bridging theory and practice. And to help us do that is Mr. Jerry Agudogo from the ITC. Let's welcome him with a round of applause.
Hi guys, it's a pleasure to be here, and like it was said, we're going to be talking about AI, machine learning, and bridging theory and practice. So I'm Jerry Agudogo, I'm a research engineer at IT Consortium, and I mostly work in the field of applying machine learning in fintech and IoT design and development, and also some hardware design, but we'll be focusing on machine learning. So obligatory definition, what is AI, right? There are many different definitions, but they all encompass trying to mimic human intelligence in some way, right? So you can think of it that tasks that we consider or think that human intelligence is necessary to solve them, it's not just mechanical machines. Well, we are trying to build machines that can actually do those things. AI, there are broad categories of AI. You can categorize things in many different ways, but one categorization is you have narrow, general, and super intelligent, right? I'd argue we're still in the narrow stage, right? So that is, can you teach machines to do one specific thing a human being can do, right? So even if a customer leaves you a review on your website, and you can have an automated system that can tell you whether that review was positive or negative, you've actually replicated something that prior to that you'd have required human intelligence to do. So that's narrow AI. Then there's general AI. General AI is a goal that seems to be quickly approaching, where AI is, machines can basically match human beings in their capabilities. So any task that a human being can do, you have a single system that can do it, right? And the goal here is that, yes, you can have many narrow AIs that can do the tasks that a human being can do, but a general AI would be able to have one system that can do it all. And then super intelligent AI, you've heard of things like the singularity. The idea is that once we have super intelligent AI, we'll have machines far smarter than us and we will be doomed. So now machine learning. So, the field of AI is long and varied. If you program a system with certain bits of knowledge and create symbolic logic rules in a program and are able to run them, that is considered AI, right? So there's a field of AI where you actually program machines with all the different rules and steps that you follow to outline a task. However, one of the issues that came up with that is there is going to be a whole lot of specifications, actually quite impossible for people to do to the level where you've specified everything, right? So machine learning is basically trying to say, well, okay, can we build systems where the machine will learn itself, right? So I'll just basically show it things and tell it the outcome that I want, but I won't tell it how to do it. And it's supposed to learn how to do it. Now, in machine learning, again, we can look at two key types. There is one where, for instance, let's take the idea of housing prices, right? Let's say I'm trying to predict the price of a house. Given the location, number of bedrooms, proximity to schools, what is the value of this house going to be, right? In that case, I can collect information about all the houses, let's say in Accra, and their prices, and then have a machine learning model say, well, how are the two things related, right? Unsupervised learning is a form of machine learning where you don't have the outcome known at all, right? So again, in looking at houses, let's say I don't have the pricing of houses, I just have properties of the houses, right? If I pass it to an unsupervised learning algorithm, perhaps one of the things we can do is group them. Let's say I don't know what a mansion is, I don't know what a small house is, I don't know what a hotel is, but you expect the machine learning model to recognize some patterns and say, hey, maybe there are three groups here. Some group of houses seem to be quite small, there seem to be quite large houses, and then there seem to be just really big, huge buildings with many rooms, right? So then you can get categories of stuff that way. And then there's reinforcement learning. Reinforcement learning is really a really cool one where you see in the robots and the self-driving cars and all that. It's basically learning through trial and error. So with this, you actually let the system live experience the world. It could be a simple world that you create virtually. But based on its interactions in the world and the feedback it gets, it will be able to improve itself. And basically get really good at doing the job. So the reason why we're interested in AI in IT Consortium, and I think it's really interesting in Ghana overall, is because, well, you see, we are more in like a knowledge economy these days, right? And one of the big problems we have is building up our knowledge workforce here, right? So having opportunities where we can have this technology that's sort of like a force multiplier, allow us to make better decisions really quickly, allow us to automate things that before you needed a bunch of humans to do, allow us to build whole new products that we couldn't build before, right? Like, I believe InGen showed the chatbot, right? I think a few years ago, if someone told you that I have 1,000 documents and I want my customer support to look for one line, you'd have told them probably, you'd have probably charged them $1 million or something at the very least. And then of course, improving safety, right? So there are things that humans can check for. One is like money laundering. Money laundering patterns are really complex. How's a human being going to look at all those numbers and analyze what they mean? If you have an automated system to do that, that's way better. Okay. So this talk is about bridging theory and practice. So let's just go over a little bit of theory. The point here is, when we talk about AI, usually you think about something like the brain, or you think someone's going to show you the picture of like a human brain or the brain of a mouse or something, and a lot of people find it quite disappointing how simple some of the algorithms look. But at the same time, that's also very encouraging, right? It means you don't need to be a rocket scientist to understand AI. So for instance, what are the tools in our toolbox? One of them is decision trees, right? So decision trees are quite simple. For instance, again, if I want to see whether I would give someone a loan, right? They came for a particular loan amount, and you'd ask yourself, well, do they have enough money in their bank account to justify giving that loan? Or do they have enough of a salary to justify giving that loan? So you could think, do you have enough salary? Yes, give loan. No, don't give loan, right? But it can get deeper, because you could say, do you have good enough salary to get this loan? No, but do you have assets, like lands, that could cover the loan, right? So if you do, then yes, we'll give you the loan. If no, then no. So you see, we're building trees of decisions, right? Another tool we have in our toolbox is this linear regression. It's very simple, but very powerful. We basically have points on a graph. We can consider them number of bedrooms in a house and the price of a house, right? How can we tell how the number of bedrooms in the house is related to the price? Well, we can use linear regression to figure out what line represents that best, right? And then we can use that for decision making. We have other tools like logistic regression. For instance, if you look at the previous one, linear regression, where it's a continuous value, and basically, whether it's 0 or 10 million, you're supposed to be able to predict it. Logistic regression helps us to determine differences between two classes. Let's say I have pictures of cocoa leaves, and I want to see, well, which of these cocoa leaves is diseased and which one isn't, right? So now I don't really want a number from 0 to 1,000. I just want to say deceased or not deceased, or well, maybe what is the probability that it's deceased, right? Is it 50%, 90%? Tools like logistic regressions help us here. It's basically like linear regression, except you see a sigmoid function over there. A sigmoid function basically makes sure that the output, if they get really big, it gets close to 1. If they get really small, it goes close to 0. Then we have another tool called support vector machines, right? So again, let's imagine that you have customers, right? And maybe you have 2 major groups of customers that you want to understand better, right? Well, how do you separate the information that you have in terms of who is in group A or group B? What support vector machines do is that they try to find a line, if you're thinking of it in 2D, between classes that best represent their separation, right? So for instance, once I'm able to arrive at this yellow line, which is the decision boundary, then I can just say those above the decision boundary are in group red, in group blue. Then we have something called naive Bayes, or that uses the Bayes theorem, right? So this is more like, well, what is the likelihood I'll have a car crash if I'm driving really fast, right? And then someone could ask, okay, well, what is the likelihood I'll have a car crash if I'm driving really fast and I'm drunk, right? So basically you have information about your data, and you have a model that's going to learn things like that. It's more probabilistic, right? If A, then B. Well, if A and B, then what is C, right? Or what is the probability of C? And then we have K-means clustering. Again, this is something that helps us find clusters in data. So back to the customer service example. If you have 2 different groups of customers, like you can see in the before K-means, I mean, it's pretty clear for a human to see, but still, the machine knows nothing about the groups. But once you run the K-means algorithm, you're going to get this really nice grouping of various classes. And there are things like hierarchical clustering, which do similar things, except that they do it from the bottom up. And one of the most interesting things, or most powerful tools we have in machine learning these days are neural networks, right? The point is neural networks are considered universal function approximators, meaning if you have the right size neural network, you should be able to approximate any function in the world. What you have, where is it? On the right is a single neuron. Basically, you just have 2 data points. Again, if you want to predict the price of a house, right? X1 can be number of bedrooms, X2 could be square feet, right? And then Y would be the price of the house. And one of the interesting things here is that you can then build networks of these neurons, right? And the interesting thing here is, like, if you look at the inputs, the X's and the Y's, right? All I really have to do is have a data set which will be the X's, and have the outcomes of the data sets which will be the Y's, right? So you can imagine a self-driving car, right? I have all this information coming through from my cameras in real time, and I want to know, well, what should I do? Should I press the brake pedal? Should I press the accelerator? Should I manipulate the steering wheel, right? And what is interesting about that, and what neural networks allow us to do, is that we just basically use the most basic calculus principles you could think about, right? Which is differentiation and the chain rule. So what is really interesting or kind of magical is that if I have my x1s and my y1s, all these things you see in the middle I can just randomly initialize, right? And then what will happen is that all I have to do is, when I have an input, right, and I get my output, I'll just look at what the difference between what the output should be and what I actually got. And then I nudge all these values in the direction which their derivatives will tell me that the final function will move down. And that, I think, we're all familiar with. You can just use the chain rule to figure that out. So that's a very powerful technique, and that's why you see machine neural networks being used a lot in industry, because once they're extremely powerful. All right. One of the things, so, this talk is kind of designed from the perspective that there'll be some people here who have learned a little bit about machine learning theory, maybe not at all, but you might be interested in building products. You've heard of machine learning. How does it fit in? What products could I build with it? So I'll just, from time to time, bring up some concepts. You can keep in mind if they're helpful. That's great. One important thing is in neural networks and machine learning is representation learning. So what you notice is that when we have the neural network, it's trying to have proper representations of data. Let me just show you an example. If I imagine this example where someone left a review on your website and it's plain English, your product is very good or your product is very bad, right? How are you going to say whether is the product good or is the product bad, right? For instance, let's say you have a support vector machine. Here we can say that, oh, all these points above this line, good. All these points below this line, bad. Well, the problem is, how do you have natural language that are points on a graph and can be separable by a line, right? So those are things that the neurons inside a neural network will try to do. So if we see this very simple neural network, you see that by the time that you get to the final layer, which has 4 neurons over there, the neural network is also trying to modify the data such that by the time you get to the end, it's easily separable. And that's very useful for us to know, especially when it comes to other things we discuss. So for instance, here you can see there are faces, cars, elephants, and chairs, right? And you can see in the neural network in the earlier layer, you only have lines and circles. And then you go to the next layer and you have more complex shapes that are combinations of those simple shapes. And then you go another layer and then you can see, unfortunately, it seems a bit too small, but you should be able to see elephants, chairs, cars, and all those things at that level, right? So you can see how it's kind of building representations. So what is really cool about representation learning is that, like I was telling you, building representation is kind of the really hard part. Once you have the right representations, the rest is quite easy. So what you can do is, and again, in practice, is you'd say, well, I read about machine learning, it looks so expensive, right? Well, one of the ways that you can really be cost effective is fine-tuning. So for instance, let's say you have some agric tasks. I don't know, like you want to see whether some plant is diseased, right, or has some fungus, right? To build a model that can learn from scratch to be able to do this will require lots of data and lots of training. But for instance, I could take this model, which you can see, or I hope you can see, has already been able to get proper representations where it can go from simple lines and circles to elephants and so on. So what I can do is I can just do fine-tuning, right? I can just cut out, because where you see the 4 neurons, that's where I expect good representations, right, to have been developed. Well, across throughout the network, right? I can cut out just the last layer, put in a new layer, and train that new layer to be able to, let's say, detect if a leaf has fungus in it or not. Because I'm leveraging the fact that I have already trained a network which is able to come up with proper representations for visual data. Another technique that you should be aware of is distillation. Training smaller models from larger models. You might have projects that you want to do some form of machine learning on. You might find that you don't have the compute resources to do it. So one thing you should consider maybe is distillation. And the good thing about distillation is that, you see, just like the teacher and student. So a teacher has to go out, learn a lot about the world, and then eventually be able to form a more compact representation that they can now come and teach you. And then once they teach you, it's easier for you to pick up. So similarly, you can leverage the fact that Google, Facebook, all those companies have trained really large models to do specific tasks. And your job is not necessarily to learn how to generalize from the whole world, but you just need to learn what the larger model has learned, which is simpler for smaller models to learn. So another thing you should keep in mind. Also related to neural networks, last point on this is multimodal systems, right? Right now, if you've used tools like ChatGPT, you can see that you can understand images, you can understand text, you can speak to it with your voice. Well, this also has to do with representation learning, right? If we came back, let's see. For instance, if I have a picture of a boy, right, and I go to a neural network, let's say, this is a bit simplified, but let's say in a certain layer of the neural network, let's say a boy standing on a beach is 1111, and it's just words. Part of building multimodal models is that now when I have a picture, I'll have to have a neural network that's able to have the same representation at that layer. When someone speaks with the voice, and it's just basically acoustic signals, it should still be processed at that layer to that exact value. So at that point, you have models which have a layer on which they have similar representations. All right. And the last one here, again, is quantization. I'm hammering on this again because one of the big problems with practical machine learning is lack of resources. So it's really important for you to be able to know that when they tell you a model requires, well, this many gigabytes of RAM to run, usually that's for full precision. And that's like each value in the neural net is being represented by 32-bit floating point number, right? But you can actually sacrifice that and maybe use 8 bits, 4 bits, even sometimes 2 bits, and not sacrifice that much in accuracy. So again, something to know, especially if you're compute constrained. What are some of the main evaluation metrics you should look at when you're applying machine learning to your problems? Well, some are, for instance, when it comes to classification accuracy, right? So you told me something was how accurate were you, right? If I told you figure out all fraudulent transactions, and you told me these were the fraudulent transactions, so I'll just see which ones were true, and that's your accuracy. We have precision, right? So precision is when you predicted, let's say a person is sick, that the person has cancer, or these people have cancer. The people you said they have cancer, do they truly have cancer, right? That's another metric. Another metric is, well, you had a bunch of patients, some of them had cancer. When you predicted which patient had cancer, did your prediction include all the patients in your group that had cancer, right? For instance, in the cancer case, you would want to make sure that your machine model is really heavily leaning towards recall. And it's also something to know if you're trying to build practical systems. And then, of course, sometimes you want to balance between precision and recall, and this is just here to let you know that there are metrics that combine both, like F1 score. When you're doing regression, like in terms of predicting prices of houses, one of the main evaluation metrics is the mean squared error. In this case, you're just basically looking at what do you predict, what are the actual values, and then sum them up and see, well, in terms of the mistakes you made, what was the total mistakes you made, right? Hyperparameter tuning is also very important in machine learning. Like when I showed you the decision tree, you can actually combine decision trees to form decision forests, right? So one hyperparameter would be how many trees are you going to have in your forest. Or when I told you that with neural networks, I can initialize the weights randomly and then slowly nudge the weights in certain directions. Well, how much am I going to nudge those weights in certain directions, right? Those are all form hyperparameters of the network, and they're important. Another very important thing in machine learning is feature engineering. So feature engineering basically means you have raw input of data, right? For instance, I can have transactions by somebody, right? To take those transactions and have a new point of, well, what is the total number of transactions you did a certain amount of time, for instance? It's called feature engineering. Or for instance, if I have a house and I have a number of bedrooms of a house, and I have, let's say, the number of bathrooms, what is the ratio between the number of bedrooms and bathrooms? That can also be a very important factor. When you're developing machine learning models, it's especially important for you to have good data, and especially important to select proper features. One thing you notice is that a lot of the effective machine learning models already exist in libraries and stuff for you to use. You just need to know how to use them. And the most important thing is what you feed them, which is going to be the data. So you have to make sure that you have proper features and are able to properly select features. All right. So what are some practical applications of AI? Like for instance, regression, like I said, predicting continuous variables, right? So this is some information about the client. What is their credit score? We can figure that out. For instance, in fraud detection, we have fraudulent transactions. You have transactions coming in. Which ones are fraud? Which ones could be money laundering? Well, we can use some of the classification algorithms I showed you to do that. Anomaly detection. Let's say we are monitoring packets in a network. I want to know whether network intrusion is happening, right? We can use anomaly detection methods to figure that out. Predictive AI, consumer demand. You have a good, you want to know what the demand for that good is going to be during certain seasons. Let's say 5 years from now. You can use things like linear regression and other models to figure that out. As some of you have known, there are new opportunities now that have come up in the area of generative AI. So for instance, when I showed you neural networks, they can be applied to natural language and even code. So you can train neural networks on code bases and then have them be able to generate actual good code for you. So I'm sure a lot of you have used ChatGPT and stuff like that to generate code. Similarly, you can have things like computer vision. You can feed machine learning models images, right? So you can say things like, well, are there cars in the picture? Does the license plate match some known license plate? Does the license plate match a license plate that is in the police database, for example, right? All those things can be done with neural networks. Then we have natural language processing, understanding generating language. So whether you're translating from one language to another or the sentiment analysis, example I gave, or the chatbot we saw from InGen, or from the natural language processing. And also something for you to think about is machine learning over knowledge graphs. This is not that much widely yet popularized in the industry, but showing quite positive results, especially in areas which have highly connected data and lots of data points, like knowledge graphs. For instance, if you're fighting money laundering, you're dealing with lots and lots of accounts and lots of people mixing money in very complex patterns. How are you going to figure out those patterns, especially if those patterns keep on changing all the time, right? Models like this can really help us do that. Other things, again, why we're motivated to pursue AI. In Ghana, we have issues with our healthcare system. We could always use more doctors, more knowledge workers in that area. So predicting, diagnosing, treatment, doing personalized medicine, predicting and managing disease outbreaks are all things that at least AI can help with, and hopefully in the future be able to do more reliably. Large language models and intelligent agents, right? Similarly, one of the interesting things that happened with neural networks is that, and you saw it in GPT-3, GPT-4, is that researchers built a neural network to try and figure out what the next word in a sentence is going to be, right? But then think of a sentence like, John gave me 2 apples, Amma gave me 2 apples, how many apples do I have, right? One of the interesting things about that's not just randomly predicting a net word, that's doing math, right? So one of the interesting emerging features that came out recently was that large language models that are trained on just next token prediction actually form representations of the world that are very useful. So what you do is you first train a neural network to figure out what the next sentence in a world is, what the next word in a sentence is going to be. Your data set is going to be from, or is actually from all sorts of data scraped from internet, Wikipedia, textbooks, and so on. Once it's able to get really good at predicting the next word, from a look at representation learning, one of the things that is build really good representations of language, the world, inside of itself. They can do fine-tuning. For instance, you can train it on a code base of, ask for a certain code block, you output that particular code block. And so that's one of the things that I think has really caused a revolution and has a lot of opportunity from coding automation, customer assistance, automating workflows, and in general, personal and corporate assistance. Just like you'd see in the movies, really, as I think what we're all working towards. AI tutors, right? That's a big opportunity, I think, for startups in Ghana. It's, educational system has a number of challenges. If we're able to have computers that are a lot better at teaching students and imparting knowledge, that'll help us to grow a much more knowledgeable workforce and really effectively. And surveillance policing, I think we'll hear about that next, so let's skip that. And the military AI robotics, right? I think we've all heard of autonomous weapons and such being used in war these days. And they have opportunities because we do have dangerous groups that need to be fought. But at the same time, there are a lot of ethical concerns about the power that these kinds of systems provide to parties. All right. So we looked at theory, we looked at a bit of theory, we looked at a bit of practice. How do we bridge the two? What are some of the main things you see when you try to bridge the two, right? Like I said, one of the main things is data challenges, right? The quantity and quality of your data. Your data is basically going, if you want to predict house prices, for example, your data has to contain a large enough variety of house prices in Accra, for example, for the model to be able to actually learn and get a good enough sense of all the possible patterns that can exist, right? If I only give it data about mansions, for example, and then I ask it to predict the price of normal houses, it's not going to be able to do it, or not as well as I'd like. Also, so you have to make sure that you get quality data and you get a good enough quantity of it. Then exploratory data analysis is also very important. There are many times you try to want to see if there's a kind image or classify cars in an image, for example, download a data set only to realize that there are like cows and dogs and stuff like that in it, right? So you could be training your neural network or your machine learning model and it's not giving you great results and you wonder why, and then you go analyze your data and you realize that actually there's a lot of noise in it. So it's very important to make sure that when you feed data or when you're working with a particular type of data, you actually go in yourself and analyze it. And you also have to make sure you take a look at ethical considerations, right? Make sure that you protect people's privacy and at the same time look out for biases in your data. You also have to So, okay. So when it comes to training on machine learning, one of the things you've got to be worried about or look out for is also overfitting, right? So you have, underfitting is easy. That is the example on the left where you see the model is just not really good at separating data points, right? You can see that sort of a much better separable from the axis with kind of like a C shape, right? So there's opportunity there to have a better model. If you look, there are circles and between them. Those are noise, right? So ideally, you'd want kind of like a C shape that keeps, that doesn't, that where, I don't think it's, or maybe, okay. It's right at the boundary of the yellow circles and the blue axis, right? However, if you train your model too long, what you can get is overfitting, right? Or train too complex, a lot of things that can lead to overfitting, but you can get overfitting where you see the model is really trying to come up with a really complex function to get all those x's, right? Which in the row, when you give it real data, then it's going to be confused. So one of the ways of solving that is having a training test and validation set, training, testing set and validation set, right? So instead of just having a training set, having a machine learning model that's really good on a training set or one set, and then you celebrate that you've done a good job, you realize that you training set and then you test it your testing set, right? So that you can see that the knowledge transfers over. Also, because you're going to do things like hyperparameter tuning and coming up with different models and so on, and to see which works best, you should put aside a validation set as well. And what this validation set will do is that once you're done training your models and coming up with what you think is the best model, you then validate it on the validation set, right? Which the model has never seen before. And what you'll find is that if you have a model that's overfitting, when you're training it, it'll tell you that, wow, I'm getting 100%, right? But then when you give it the real data, it won't do so good. So this is one way you can kind of avoid that. One thing you should also think about is automated machine learning, right, or AutoML. The AutoML services that companies like Google, SageMaker, Microsoft, or AWS Microsoft offer, but also mean more in understanding how certain tasks that you carry out can be scripted, right? So for instance, you see that when you look at AutoML, the approaches for making sure that all the steps you carry out during data processing, pre-processing, feature selection, model selection, hyperparameter tuning can also be automated, right? Which gives a big productivity boost, you know? Especially if you have, in a situation like us where, for instance, you can have many different merchants where you want to develop models for, it's quite difficult for a human to take data sets from 200 merchants and then process and understand them independently. Model deployment and scalability. So when you build these models on your computer, on a machine in the lab, that's really good, and that's quite some progress. But then one big challenge you also notice is, well, how do you really move this into practice? Because the thing is that in practice, this thing is going to have to be deployed, applications are going to have to be able to talk to it, it's going to have to respond in real time, a lot of the time. And so you have to make sure that you're familiar with cloud computing, you have to make sure that you're familiar with distributed file storage like Amazon S3, you have to make sure that you're at least a bit familiar with how to host basic applications on the cloud. A machine learning, most of the time when you have a machine learning program, it's just going to be a Python application, right? So learning how to at least host Python applications and do things like continuous integration, continuous development would really help you as well. Then also when we look at scalability, you see that, well, processing large-scale data in real time is not that easy. Sometimes you might want to make a decision on, let's say, an example of transactions. You want to say, well, I'm processing transactions, and which of these transactions is likely to be fraudulent? Well, what if you have, I don't know, 10, 100 transactions a second? You're going to have to make this determination in milliseconds. In addition, you're going to have to calculate a lot of features about a transaction. Like, for instance, how much did a person transact in the last hour, and so on. So in order to be able to do those calculations effectively, again, you're going to have to get familiar with distributed file storage. You're going to have to get familiar with distributed file data processing frameworks like EMR and real-time processing frameworks like Apache Kafka. At least being familiar with those tools will help you know when to reach for them. when you are in need. Okay. Now, one very important aspect of AI that or in terms of AI in practice that you should pay attention to is explainable AI. A lot of the time, people find themselves in trouble because they get this really good AI model. They say, well, I can predict, I don't know, whatever you wanted to predict by like 99% accuracy, right? And then your stakeholders will tell you that, well, let's say credit. I want to give someone a loan. And I say, my model actually can predict with 99% accuracy whether the person really pay back the loan or not. And then you ask the person, oh, okay, so how does the model work? Like, well, I don't know, but I know it has really good accuracy, right? Or the person tells, well, why did the model actually say the person can't give back the loan? Is it the money in the account? Is it the work that they do with their salary? You say, well, I don't know. You can't say you don't know. So because of that, you have to make sure that even now you look into interpretability. There are techniques like SHARP, LIME, and so on that you can look up. You'll find many blog posts on those. And also, one of the things you should also make sure that you always do when you develop AI systems is you have to report the failures of the system and the limitations of the system, right? Reporting only the successes is really bad practice and can really help you lose, or can really lead to you losing a lot of trust, and at the very least. So make sure that, and what you're going to find is that no matter the model you develop, it's always going to make mistakes. And you have to make sure that when you're communicating information about the model to your stakeholders or whoever, even clients, to make sure that you at least touch on the limitations. So what does the typical machine learning model lifecycle industry look like? Well, like I said, the most important thing is data. So you've got to plan the project and collect all the data that you need for the project. Then you develop your model. Then you validate your model. Then you deploy the model. Then you monitor the model's performance. You maintain it. And part of the maintenance is continuous retraining and so on. And as you're running the model in production, you're going to be collecting more data. You're going to be collecting more information, and that is going to feed back into improving your model, validating the improvement, deploying the improvement, monitoring the performance of the improvement. So it's a never-ending cycle, is my point. And when you develop a machine learning system for anything, you have to take that into account, especially when deploying it into production for a real system. For instance, coming to the idea of housing prices, right? Well, the economy of Ghana is going to change. Factors change. So just having a model that I trained on housing prices, so I got data from somewhere else and I trained it on housing prices, so I've done a good job. That's not enough. You have to be aware that there's going to be some drift in your data. All right. So if you're here and you're a student and you want to get started with practical machine learning, how should you start? Well, I just want to draw your attention to the fact that there's something called Google Colab and Hugging Face notebooks. And these systems allow you free access, right, to actual machines that have GPUs in them. And because of that, they're a really good starting point for small projects. And I don't think, just an idea that money shouldn't deter you. At least for the basics, smaller models, really getting a good understanding. You don't need large compute. Yes, there are certain things like, what OpenAI is doing with ChatGPT and so on, or really complex computer vision models that require a lot of compute. But again, you have a lot of tools in your toolbox, like quantization, like fine-tuning, like distillation, right? So there's a lot you can do with smaller projects and for free with Google Colab and Hugging Face notebooks. You should also look into Jupyter notebooks if you're not familiar with that. It's really going to help you speed up your iterative cycle, coding, data analysis, visualization. And you should get familiar with some basic standard libraries and frameworks like scikit-learn, PyTorch, and in general, you should familiarize yourself with Hugging Face Model Hub, right? So Hugging Face Model Hub is one of the largest repositories for open source machine learning models in the world for all times, whether it's computer vision or learning from tabular data, financial data, you can find it all there. So if you ever have let's say a use case, for instance, I want to, do some translation to another language. You can go to Hugging Face Model Hub and just take a look at the models that are out there. Another thing you can do is look at Kaggle competitions, right? So Kaggle is an online system where you basically have machine learning challenges, right? So they have machine learning challenges, there's associated data, and the community of people and researchers and students and so on are supposed to come together and try to find real-world models, machine learning models that actually do really good in the real world. So I'd recommend that as a first stop for anybody who wants to see machine learning in the real world, right? Just pick a problem that's close to what you're interested in. I'm pretty sure there's going to be a Kaggle competition that at least in the last 10 years was hard on that. You can just see how they solved it, right? And actually, as models develop, one of the main ways researchers show that their models are an improvement is to go and actually do better on that same competition. So it will give you a really good insight into what the real world problems are and how people approach it in the real world. We're also reading research papers. You know, a lot of us have problems reading research papers. I don't know if you can call yourself literate, you know. Like, you know, literacy is not just being able to read words. Literacy is also being able to read, I don't know, especially for an engineer, materials and texts that are relevant to us, right? If we're only getting information from YouTube videos, it's going to be very, very limited. Often you'll find that even those teaching you the concepts might actually not have as in-depth foundations mathematically, theoretically than you have. You know, they've just struggled through actually like reading the paper. So you should make a habit of that. If you can even read one paper this year or in 2 years, it's cool, but just get started. Eventually you get good at it. And then also make sure that you're familiar with cloud services, right? And eventually your laptop and your machine, your personal machine is not going to be enough. You're going to need cloud providers or machines provided by cloud providers. So it's also good to get familiar with them a bit by bit, right? I think as you're trying to be entrepreneurial, as you're trying to come up with interesting projects and solve them, you might not know exactly what the technology you're going to require is. But if it's going to involve machine learning anyway, it would be good to know, again, the tools in our toolbox, right? And so one of them is just at least try to go to AWS and just deploy a simple Python application, right? Just to get or Google Cloud or whatever, to get a taste of that. Another interesting thing is AWS has a service called SageMaker Studio. Google has similar services. A good thing about that is they are managed platforms that are supposed to help with managing the whole life cycle of AI model development. The benefit of that is, you know, when you go to SageMaker Studio and you see they have features over there, you can Google and try to find out why do they have this over here, right? And that can also teach you about certain things that are done in production that you might not necessarily get just through an article or something. So that's also worth knowing about. And the last but not the least is ethical considerations, right? When you're putting AI into practice, again, one of the biggest challenges is data, and one of the second biggest challenges is ethical challenges, right? So you have to make sure your systems are unbiased and fair. There are a lot of ways that bias can creep into your models. I think the ones that we are all familiar with and kind of hit home is how black people, you know, I think policing models in America can kind of tend to, or in other countries where, you know, there tend to be, let's say, immigrant populations that might not be doing so well or have a higher likelihood of crime in certain areas. If you see that there's data collected from those areas, now just because you're black, the police will be stopping you all the time, right? Which is crazy. There's the same thing in Ghana, right? You might think, oh, that doesn't apply to us, but then you might see that, actually, your model might be biased against some people from some region or something. Like right now in the north, they have a bit of challenges, right? So if you were to train a machine learning model, let's say during the time frame that the north had challenges, you see that it would probably tell you not to do business there, right? Which again, it might be biased that's leaking into your model. Cultural representation and influence is also very important, you know, especially in the era of things like ChatGPT and these large language models and assistants that people are going to be talking to. Eventually, a lot of us will have, especially kids, or care about the children, and it's important that you know, the models that you develop, at least you should be aware, right, of what kind of cultural representations and influences exist in the model that was developed, and make a decision whether that's appropriate for you or not. Transparency and accountability, I spoke about that. Always make sure you highlight your challenges. Data privacy and security, you have to make sure that people's data is safe at all times. A lot of times, your machine learning model will require data from people, a lot of times sensitive data. it's really important for you to also start thinking a little bit at least about data privacy and security. And not too much, but enough for you to be aware of what to look out for. Another ethical challenge, especially, again, here in Ghana and also elsewhere around the world, is job displacement, right? As AI is going to take more and more of our jobs, we are all going to have to think about what that means and how we're going to navigate that as a society. So thank you very much, and I hope at least it was helpful.
Thank you very much. So you can join our panelists upstage. We'll have our final presentation for today. That is going to be... Okay. Amazing. So now we've learned about machine learning. Our final presentation is going to be on leveraging on the power of AI in security and surveillance. To help us do this, let's welcome with a round of applause Mr. Stephen Beatson from Security Shade Limited.
Thank you. So thank you, Mr. Jerry. You've actually made my presentation super simple. You've really elaborated on everything I wanted to say. So this presentation is actually going to be brief. So I am Stephen Beatson from Security Shade Ghana Limited. What Security Shade does is we have extensive experience in physical installation, computing, deployment. We also do infrastructure architecture, and our core values are we really want to satisfy the Ghanaian market, and we want to get in there and partner with industry partners to be able to leverage more on the AI and the tech ecosystem. So today, I'm going to take you through the reasons why leveraging on the power of AI in security and surveillance will bring about transformation in our institutions, in our communities, and in our country at large. So this is how I'm going to do it. The introduction, the why AI in security and surveillance, then the evolution of security systems, real-world applications, challenges, privacy and ethical concerns like Mr. Jerry cited, then addressing the challenges, then the future trends, then the end notes. So let's dive into this. So leveraging on AI, we've actually come to a point where cutting-edge technologies are revolutionizing the security and surveillance industry. And also from the intelligent monitoring systems to autonomous security drones, artificial intelligence is enhancing our ability to detect, deter, and solve real-time threats. And fusing this with the camera system really goes a long way, like I said before, to protect our institutions, our communities, and our country at large. So why AI? AI in security systems, AI-powered security systems actually identify individuals by facial recognition, by detecting behavioral patterns, and also it works hand in hand with deep learning algorithms and neural networks. So let's take a brief history of the evolution of security systems. Previously, we had analog cameras for monitoring, which only had motion detection ability. Then came the IP evolution, where we could have motion detection, but we had more, where there could be region entrance, there could be region exit, there could be line crossing functions, there could be baggage exit, baggage removal, and the system could also study scenes and inform command command centers that, okay, an individual has left a bag, or this individual is trying to maybe leave something that would cause damage to a particular property. But what kept reoccurring is, during the analog era, we still had human beings heavily relying on the cameras, that they have to monitor the cameras 24/7. That's still happening with the IP networks. By fusing this with AI would reduce the time a human being will have to sit behind the computer or the monitoring scene to check real-life events, real-life threats, if something is about to happen. This time around, the AI utilizes extensive data and captures detailed information where it would prompt the command center that, oh, okay, this individual is of no threat. This individual is of a threat. And doing all this has brought massive evolution to the security and surveillance industry, because previously the analog cameras could, when you set motion sensing, the analog cameras could just trigger false alarm, which that's not what we need. Just by changing temperature, rainfall, wind, the grass just shaking and all that will trigger false alarm, which we don't need that. But the evolution of AI has brought intelligent and deep learning algorithms that helps classify target objects, where the rain can start falling, change in temperature, all those I mentioned before, and it won't trigger any false alarm. So we are evolving. So like I said, object detection. This object detection and surveillance helps detect objects. Probably, let's say, okay, this is KNUST, and we are having a seminar here. We all brought bags. We are all expected to leave with our bags by the time the seminar ends. But whilst the seminar is about to end, with almost everybody's out, but there's one particular person who's still seated, and he walked out without taking the bag. If you've set an intrusion function or you've activated the object detection functionality, it would trigger and send a command to the control center, which will then prompt the security personnel available to promptly get in touch with the individual and ask that, why have you left your bag here? And we don't need this here at this particular time because the auditorium will be closed. So that's one of the advantages. And also behavioral analysis. This behavioral analysis works in a way that, okay, let's say here's a security zone. Then we have somebody loitering around the security zone. The manner in which the person is walking, or the moves the person even decides to make, the algorithm that is built in the AI will be able to identify that this particular person poses threats or not. So if the person doesn't pose threats, and even if the person poses threats, because you have not set a particular smart function that states that, oh, okay, if he doesn't leave the region in 5 minutes, I should trigger an alarm, nothing will happen until that particular function has been set. Yeah. So, and like I said, yeah, identification and tracking. The AI-powered camera can identify individuals and track them in real time. Provided, let's say, okay, we have watch list individuals where the government has put out maybe a bolo, or maybe they probably want a particular person that they've not really been able to capture for a while. Then they put out an alert, and all the security surveillance cameras that have been integrated with the AI system will send a command to the control system anytime that person is spotted out. there. So this is, yeah, like I said, even at the airports or the borders or high-risk areas, this information will be sent out there. An automated watch list, like I'll skip this. Then vehicle recognition. The AI-powered CCTV cameras have the ability to identify license plates. And this, in the long way, goes to help industry players fusing with governments, governmental organizations. It also goes in a long way to help them in such a way that, okay, we have yearly license registration. So let's say you're out of license, and maybe the government has integrated the AI camera system into their control center. It would prompt them that, okay, this vehicle's license is about to expire, so they'll be watching out. The moment it expires and you still don't come back to them, they will be able to track you down, or the moment they see that the car is on the road, they will identify the particular region you are, and they will get to you, then the necessary steps will be taken. And so autonomous systems, the AI-powered cameras also works in such a way that, okay, I've mounted a camera here. There's a lady sitting far behind there. The AI system has detected that, okay, she's acting fishy. I wouldn't have to go back to the control center and zoom in to see exactly what she's doing. The moment the AI-powered camera sees what she's doing and the camera feels that, okay, I have to really get the detail of what that lady is doing there. The camera will automatically zoom in, then we'll get all the needed details. Then if it's a threat issue, to send to command. If not, it will just bypass it because it's of no threat at all. And also object tracking. Let's say this same auditorium, we have students coming in, and there's a particular student that the faculty wants to monitor. The moment the student enters this particular room, the camera, wherever the student is working, the camera will follow that student to see exactly where the student is going to sit. If the student acts fishy, or if the student is of a good behavior, the camera will identify all that. So when it comes to the faculty to really check how the students acted here, they'll just search. Maybe they want to find a particular person. So during the previous era, the old systems will not be able to identify human and objects, but with this AI evolution, you can just search, okay, humans. So you can even put in your timestamp, because you know the time. The AI has already alerted you of that particular student. So you put in the timestamp, and it will just go there straight up. So coming to the ethical concerns my brother raised, privacy invasion. Let's say, I think, there are many cameras mounted here. I believe some students might say, okay, you are invading my privacy, why are you monitoring me and all that? Those are some of the challenges we have. We have people who have installed cameras, and they've not warned the individuals that, okay, you're under monitoring, so you better behave. Because your feed, the moment we put there, you're under monitoring, the feed we have, we can use it for any purpose we want, because we've stated it out there that we are monitoring you. And like you stated, the bias in discrimination, and I remember we've had instances where we've done an installation where we set, it was a high-risk area. We set the behavioral patterns, and we had people from a different ethnic group that always keep triggering the alerts, but there was no threat. It was just because of how they dressed and how the manner in which they walk. You might think the neural network, the algorithm thinks that particular person is of a threat, but it comes to, we actually found out they have no threat. So these are some of the discriminations AI brings in. And the industry partners, we know we are working on it to curb it. So addressing it, so like I said before, ensuring compliance with the data privacy regulations, that you have to let the people know that they're under monitoring. Then the ethical guidelines. For that, it's a work in progress, because people of a particular demographic group will not change the way they dress because you have AI monitoring them. So the system would I believe, it will be built, able to suit them as well. And you made mention of explainable AI here. So explainable AI in surveillance is also in such a way that we are looking at the AI algorithm in surveillance to be more transparent and understandable, because we have some personnel in the security industry that cannot really understand the purpose of which the AI camera is capturing this particular person. So all those are work in progress, and that's part of the explainable AI. And integrating with other technologies. That's the future. Imagine being able to integrate security cameras in, let's say, a traffic zone where the cameras will be able to direct it will be able to turn on the green lights, turn on the red lights. It will make movement and traffic flow. And also, the future trend, there's this setup, Security Shade and KNUST trying to introduce to the Ghanaian market, that smart education solutions, where we have cameras capturing class attendance without paper, without the teacher or the lecturer standing before the class wasting 15 minutes to mark individual attendance. The camera itself will be able to scan the students while the teacher is lecturing. Then if a student is late, the particular project guys will work on, I think, an app that would link with the student apps, and to notify them that, okay, today you are late for class or you did not attend class. And after 3 attempts, I think I would send a message to the faculty, then either you'll be excluded from writing a midterm, or you'll be warned, or I don't know the particular process that will follow. So imagine fusing that with academia, and also imagine AI-powered cameras fixed at hospitals where individuals come in. Sometimes you go to the hospital and you really join a long queue. Then you have cameras that can detect that, okay, this particular person, the temperature is so high that the doctor or the nurse has to see that particular person. All this goes in a long way to help the Ghanaian community. And also, training and adaptation, preparing personnel to utilize the AI in surveillance. And my end note, while AI in surveillance offers valuable tools for enhancing security, it also raises ethical concerns, which we've really mentioned and spoken about several times. And we want to strike the balance between the crucial needs for AI deployment. And my final notes, I want you students to know that AI is just not a technological marvel. It is a crucial tool to identify high-risk areas, high-risk individuals, and also, in a long way, it will go to help our institutions, our country at large, and also in our daily lives. Thank you.
Thank you very much. Now the floor is open for questions. If you have a question, kindly come up to the front. Okay, let me bring the microphone down.
Thank you very much for the insightful presentation. We have one big problem with toll booth or tolling. And you talked about tracking objects, tracking vehicles and stuff like that. The government even tried to even do away with toll booths because of the traffic at the toll booths. But we believe that with AI technologies like this, we should be able to automate everything like it's done in other countries, developed countries, where there will be a boom, you just pass, there's a detector that detects. But there's one major problem, that is the object that needs to be detected. What type of device or scanner or badge that needs to be on these vehicles to make it easily accessible for the detection to be done, for every vehicle to be captured when they get to the toll booth?
So please, if you have another question, kindly come up.
So thank you. That's a very good question. But the answer to it is pretty simple, because DVLA has the license plate of every car that is registered under them. And if we fuse this particular data and integrate it with the surveillance system, the moment you get there and scan, okay, let's say we integrate the Ghana card together with the license. The moment you get there, you scan with your Ghana card, then it will, I think we can use, I don't know if very soon we'll be able to use the Ghana card for payments. If you place the Ghana card in there, it opens the boom barrier and also identifies that this particular car has crossed this, border. And not only security, not only for security reasons, but also linking maybe our neighboring countries, because I believe before a car crosses our border, it's the country, the borders know about it. So we would have their license plate that, okay, this particular car is roaming in the country. So all this will go a long way to curb the tolling, the cars that join long queues before they cross the tolls, yeah. So there's the answer to it. We have to integrate the data DVLA has into the camera system to be able to identify the license.
Thank you very much. We'll take the next set of questions. I'll take about 3 questions for the next. So if you have a question, kindly come up to the front. I'll give you the microphone so you'd ask your question. Okay.
Thank you very much for the beautiful presentations. I don't know if my point are questions or recommendations. Starting off with the issue of product push and the risk it poses. I think to a large extent, we'll do very good market research. We'll minimize these things. Taking the example of what happened when the Japanese wanted to introduce Lexus into the American market. They had to send close to about 1,000 students to the US to study the kind of fabrics they want, the kind of interior they want and all that. When they introduced the product, they couldn't resist it. They bought into it. So maybe going forward, if we begin probably to look at market research very well, we would minimize the risk of consumers rejecting a product, because we'd have done a thorough work to understand all the potential risks associated with acceptance or otherwise of the product. So I think that's the very first thing we probably think about. The other one would have to do with the issue of legality. Talking all through, the issues of standards and legal issues are critical, especially in the area of AI and machine learning and all that. Globally, we might have some standards, but locally, what do our laws say? For instance, Data Protection Acts and all these things are critical things. So I think we should be clear in our minds that you can't just go ahead developing products without recourse to the laws and the regulations that exist in the country. And again, the standards that are set by whatever body is mandated to do that. So I think that's very important that we take that about all this in product development. My last one will have to do with the issue of affordability of products we develop. Because you see, when the lady asked about the product push, you talked about the viability, which has to do with the finances. Because whoever is going to buy or take the product and scale up is looking at profitability. That has to do with ability to pay and willingness to pay. And I think these are critical elements we need to understand. You can have a very beautiful product, but if it's out of reach of people, they can't patronize the product. So it ends up on the drawing board. So I think as we think through all these things, we need to also be minded by these critical elements for effective product development and introduction into the market. Then with yours, regarding the technological depth, you cannot avoid that. It will happen anyway. Because that is why you would realize that in product introduction, you introduce the product, over time the product matures, then over time it declines. So all through the product life, you have to really be alert to the changes and address them. So I think we need to be minded by this fact that it's not a one-fit-all, or it's not an event, it's a process. Once we get that, it helps us develop very good products that are usable and that are also sustainable in the long term.
Thank you for this opportunity. My question is to Mr. Jerry. Please, you talked about AI regulations and from first world countries where they have, I'm a biomedical engineer, so looking at the health sector, from the first world countries where they've integrated machine learning and AI into the biomedical engineering sector, they have problems with, let me say, the black demographics. Because from a research I read from Lancet, they were like, when they are comparing health risks for whites and blacks, the blacks, they associate them with the same kind of, let me say, illness rate, but maybe the black will have a higher rate than the white. But with here, if you are trying to push that here, with the mindset that if, like we are third world country like this, how would that be liable to, let me say, our sector, we being blacks? Because if from a first world country, they're having that kind of problem, how will you be able to preach that over here? Thank you.
Thank you very much.
Okay, well, so we have to consider where the problem is coming from also, right? When you have a situation where you have a country, let's say 95% not of African descent or something, and 5% of African descent, no matter how fair someone wants to be to you, you still will be kind of underrepresented, right? So I think that one of the solutions is to really build our own in-house solutions, right? We work with our local hospitals, our local doctors, local data. And the good thing about ML is, again, it's more about the data that you provide to it, right? And again, I also touched on the exploratory data analytics, because even in our local data, you still be able to notice, let's say, biases in the data, maybe towards certain demographics or certain features. And so really, I think the solution is building out a very strong core of ML competence in the country, right? And I think the regulations will also follow. You know, often you see industry leaders actually have to consult with government and, you know, have committees and so on, and over time, these regulations actually become solidified. But a last point would be that I would also, when looking at ethical issues, try to stick with the most ethically restrictive framework, maybe. I don't know if that, but for instance, let's say GDPR, right? GDPR has a requirement that if I want to delete my data from your system, I should be able to do it, right? So I think it's good practice, even if you are in an environment that's not bound by GDPR, to make sure that you implement those things into your system. Because these things follow certain core principles about human rights, privacy, autonomy. And when you get familiar with the actual field, these things, even before the regulation catches up, you will understand the ethical and philosophical principles behind that actually lead to these mature regulations in the end. I think those are the things we need to focus on.
Thank you very much. I would give room for one last question, and then would bring this session to a close. So anyone with a question, kindly feel free to come up stage. I would give you the microphone to ask your question. Okay, so I think I have no one coming up for a question. So I'd like to say a very big thank you to our dear panelists for such a very informative session. We are grateful for making time to share with us all of these. Now, before we bring today's session to a close, we have a very short presentation by Solar Taxi. This presentation is going to be given by Miss Givens Minta Menu, who is currently the Chief of Staff of Solar Taxi. She holds a degree in political science and French from the University of Ghana, Legon, and has furthered her studies with 2 diplomas in the university in France. With over 6 years of experience in administrative roles, Givens brings a wealth of knowledge and expertise to the table. Please let's welcome her with a round of applause as she represents Solar Taxi.
Hello, everyone. Hello, everyone. Good afternoon to you. Okay, so apologies from my CEO, Mr. George Appiah. He was supposed to be here today, but he had an impromptu meeting that he has to go to. So my name is Givens, like she rightly said. I am Chief of Staff at Solar Taxi, and I'll be stepping in for him. This is a brief presentation on Solar Taxi. So Solar Taxi was founded by George Appiah. He's one of your own. He's good here in tech, and then he came up with this brilliant idea. What does Solar Taxi do? So Solar Taxi is an e-mobility company. What we do is we design, manufacture, and assemble electric vehicles right here in Ghana. So when you see electric cars, motorbikes here in Ghana, and it's branded, it's electric, then it's from Solar Taxi. Career prospects. So from designing, especially to our engineering students, we have mechanical engineers, electrical engineers, chemical engineers, software engineers here at Solar Taxi. You can start with having an internship with us, and then from there, your competence, your national service, then we can look at employing you further based on your performance. And then what programs do we have for the youth? We have 2 major programs. That is the EV training programs for males who are interested in engineering. And then we have the Female Engineering Academy. That is our flagship for women, young women who are interested in engineering. It is free. You come in, and for 3 months, we train you in everything that you have to know on assembling of electric bikes, maintaining of electric vehicles, free of charge. I thought I'll get a clap because it's free. Okay, so before anybody asks why only women, the goal is to bridge the gap because engineering is considered as a male-dominated field, as fields where women do not venture. And even in our local setting, when a woman is into engineering, she has some frowns and some eyebrows, like you will be barren, I can't marry a woman who is an engineer, it's a man's job and all those kind of things. Those things are cake. We don't do that anymore. So Solar Taxi is here to empower our women that yes, you can. Can I get a clap from the women? Women, are you here? Yes, you can. So if you are interested, you just sign up with Solar Taxi, you'll be shortlisted, and then we'll give you the training. And we are not leaving the men out. This is what we call positive discrimination because you already have the numbers in the field. So we want to just bridge the gap. And then what other thing would you guys like to ask questions? Research prospects. So can somebody do a research into Solar Taxi? Yes. You can have a research on especially charging stations and whether the nation is ready and has the capacity to, we're looking at the electricity that we produce in Ghana. Do we have the capacity for charging stations? Is Ghana ready for EVs? All these are some research topics that you can explore. I think I'm going to end it here. I don't know if I'm allowed to take 1 or 2 questions, but that would be fine. And then we can take it from there.
Thank you very much, Givens. I'd like to know what are the minimum requirements for the female training program?
Okay, thank you very much. That's a very good question. So the minimum requirement is an SHS certificate. The person should be able to read and write, and then should have an interest in the engineering program. And then you should be able to transport yourself to the location of the training. Because we don't want a situation where you start the training and you're like, I don't have money for transportation, so I'm not coming. So that is one of the requirements that we don't joke with. You should be able to prove to us that you would be able to start and finish the program. Thank you.
Thank you very much, Ms. Givens, for such an insightful presentation. So we are bringing today's session to a close. Before we do that, we would receive our head of department very short closing remarks for today's session. Please let's welcome him with a round of applause.
Good afternoon. Good afternoon, everyone. Yes, so I'm sure that this session has been very useful. We started this Tech Week with a theme, from the breadboard to the boardroom. And for those of us who are strangers here, the breadboard signifies things with prototyping, ideation, those of us in engineering. And we know what a boardroom is. So what it means is that how can we take things from prototyping into what? Viable businesses or sustainable businesses. Most of the time we say that I have a brilliant idea. Most engineers say I have a brilliant idea, but we don't know the business side of the idea. And we have come to understand that a brilliant idea, innovative solution without a solid business proposition is just a hobby, okay? So most of us, the things that we have been claiming are brilliant ideas that can change the world are actually hobbies. So we want to move from that point to what? Businesses, okay? And so that's why we embarked on this journey with our industrial partners. Yesterday we started with exploring innovations, and our keynote speaker spoke to us about taking innovation to viable businesses. Today we are looking at product development and all the things we've spoken about, from design thinking to product life cycle to things on AI, from the security perspective and all those areas, are just to inspire us to know that yes, the things that we see out there went through certain laid down processes. And even the products that we are still using, we are still not happy in quotes with it. We are still in the process of making them useful and more profitable. And I hope that we are still learning from that. The objective of this kind of engagement that we have every year, one measurable we want to look at is how many of our so-called ideas or hobbies are we able to convert into sustainable businesses. For us as a university, as a department, we want to move away from looking at the people we graduate to the kind of businesses we influence. I think that would be a good metric for us. Let's say 10 years to come. As an HOD, I should be able to count the number of millionaires or billionaires we have influenced. In that case, when you see a letter from me, you'll not be frowning, but because we have been part of your success. And that is the kind of thinking we want to engage and embark on. With our partners, we also don't want to be, every day you see a green letter from us, give us money, give us money. We also want to get to the point where we co-create with you. We add value to what you do. We don't expect you to have all the solutions. We expect that we work together so that if today you were at position number 2 or maybe number 10, by working with us, tomorrow you are number 5. So then you see the value in investing in us. That's the kind of relationship we want to build. So we have an ecosystem where there is a symbiotic relationship. And that is the journey we want to embark on from this conference, or week, as we call it. So I hope that things have been successful thus far. But as we said today, one of the things when it comes to product development is to check feedback. We design a program, you all have the program outline, but there are some development that demand some tweaking to the program. So you saw one, Givens came in early. Yesterday we realized something with the closing session. So today we will be, when we step out for exhibition and we go to the breakout sessions, we will see some of our industrial partners in the breakout sessions. Yesterday, because of some technical reasons, that couldn't happen. So the students here, don't be sad that you didn't see any of these guys here. Today they will come. And so for that reason, we are going to make some slight changes to the program. We were supposed to have 2 talks afterwards. We're going to have one, a short one. And it is going to be a conversation on the process that we go through to make our product as a university. Our product is the students. And so we're going to discuss how we mold and shape our students. And that is what we have termed made by the process. So that's when we go out and come back, we will be talking about made by the process. It will be an interactive session, and we expect all of us to be here to make inputs. Because the objective is to make or build a viable product. In this case, our students who are fit for the market. Thank you very much. And so from here, we'll go to the exhibition, then we'll go and have lunch. Those of us in year 1, 2, and 3, we're going to have your ACES and BMS. When we say ACES, the Student Association for Computer Engineering, and BMS is for biomedical. We'll be having a program here when we are in the breakout session. You are free to come in and listen. The details will be shared online. By the way, whatever we're doing is also online, but we want the physical, So those of you whose parents can watch you in your defense session or presentation, share the link with your parents so that they know what you did with your 3 years or 4 years here. The monies you call them to ask for and all that. They are not just coming in for graduation. They should be part of the process. Okay. Thank you very much.
Thank you very much, Prof. All too soon, this morning's session is coming to a close. But I'd like to encourage us that even though we are leaving here, don't leave here without getting to know someone. There's so much value in networking. We've not only come to receive, but we've also come to build network. Our speakers are around. Kindly make it a point to speak to them, ask questions, find out how they did it, so that we can also become as amazing as they are today. So kindly rise to your feet as we say the closing prayer, and then we'll go for lunch. Exhibition would be happening in the exhibition rooms, and then the breakout sessions follow, as Prof rightly said. We'll also be taking photos after this, so please don't be in a hurry to leave. Feel free to take photos with our speakers and all our partners who are around. Shall we say a word of prayer? Father, Lord, we thank you so much for an amazing session this morning. As you continue throughout the day, let your presence be with us. Let us have an amazing day. In Jesus' name we have prayed. Amen. So we have closed. Let's go for our lunch. Let's go and check out the exhibitions. And then we'll be back here for the I conference as well as the presentation and discussion. We've not closed, please. We are just going for a break. We'll be back. We'll be back.
Nana, then may have been a sick happy
champagne. Also, the Sanka Pitonation. I don't tell me that they get her come for. What tell me?
Fino, tell me some more money. No more. Open your 1 million Ghana cedi. No. Ghana
Everyone is trying to win millions in the Telecel More Money promo. Win daily and weekly when you reload your mobile and broadband bundles. You can win up to 30,000 Ghana cedis weekly or the 1 million Ghana cedi grand prize. The more you reload, the better your chances of winning in Telecel More Money promo. Dial star 500 hash or opt in on the Telecel Play app for free.
91 million!
Telecel, connecting energies. This promo is regulated by the NLA on the Caritas Lottery platform.
Just do it now.
Transform your business ideas into success stories with Telecel Business. Choose from a wide range of products and services tailor-made to drive your business. Call 0302-233-4040 or email to business@telecel.com.gh to sign up today. Telecel Business, connecting opportunities, connecting goals, connecting businesses. Telecel, connecting energies.
Just do it another way. Do it another way. And do it a smarter way. Do it a smarter way. Just do it another way. Do it another way. And do it a smarter way. Do it a smarter way. Just do it another way. Do it another way. And do it a smarter way. Another way, do it another way, and do it as my.
Hi, my name is Tom Gustinis. I'm the CEO and founder of Fourth IR. It's an artificial intelligence company. We call it applied intelligence because we're looking to not only leverage the technology from an academic perspective and a research perspective, but to put it into use in real-world applications. We came to Ghana about 5 years ago. I came to Ghana as the chairman of a foundation that supports entrepreneurs in developing countries. One of the problems that we were trying to solve is that our main corporate headquarters is in Germany and in Switzerland. And when you look at
Engine is an IT outsourcing company. We provide high-level IT support to corporate clients in Europe using mainly Ghanaian technology talent. It serves two purposes. The first is that it provides employment to Ghanaian talent and provides training and exposes them to cutting-edge, high-level, high-quality technological practices in terms of resolving client issues, but also providing solutions and sometimes crafting solutions that are unique to whatever problem they face.
InGen is an organization that is founded by 4 different partners. All of us, even though we come from very diverse and different backgrounds, believe in the one same thing, and that is that we understand the demand for IT services in our home countries, and that is the US, that is the UK, that is Switzerland, that is Germany. And we understand that there is a need, a sense of urgency. And we believe that this need can be serviced out of Ghana, as an example, out of Africa, out of the area on the planet that is growing the most in terms of human talent?
So we decided to come to Ghana really by chance because the Trestle Academy has been here for a number of years and has been running hackathons, and they've built a network here. And through that, we got some experience of some really great people. And a number of us have been involved in building delivery centers and IT centers around the world. And we know that the core of all these centers and good quality is about people. And through the Trestle Academy, we realized actually, there's some great people here. So Fourth IR hired some people initially as like a kind of a trial. And then we realized, the view that we had, there were good people here, was really correct. So it was a chance move through the Trestle Academy, but that's really what gave us the kickstart to investigate further. And then we decided, from a strategic point of view, this is a great place to be.
At Engine, we believe in Ghana because the young population we have in Ghana are very much interested in tech. They are very enthusiastic, and they are also very teachable. The young people in Ghana are very teachable. They are ready to learn. They are ready to take up new challenges, and also they are really flexible when it comes to adaptation. So we believe that if we are able to get a critical number of these young people and train them and connect them to our clients abroad, they will also be able to contribute to the tech ecosystem here in Ghana that is fast developing.
4IR Ghana is the AI ML agnostic company, software company. We are into the development, management, and deployment of AI solutions in Ghana. We happen to be one of the premier clients of Engine Ghana Limited. We are very happy as a customer of Engine. We have a very good environment that helps us to work efficiently in a co-located environment that we share with other companies. The services are awesome. The co-working environment is equally amazing.
I joined the company not quite a long time. It's almost 2 years now, and it's been wonderful so far. When we started, we were 2, but now there's been a lot going on. We are now 12. As time goes on, there's a lot of people coming in. You get to learn from other people because everyone is having their own part of experience, and then you get to engage with team, and then it's been one happy family.
I joined Engine 6 months ago, and it's been great being here. I enjoyed the exposure working with companies like Adidas and interacting with enterprise-based systems. Also, it gives me the opportunity to learn. There are great learning curves here, and gives you the chance to meet great and other good engineers as well. I will encourage everybody who has the chance and the right expertise to learn or to come work with Engine interview.
Since joining Engine, I've received various forms of training, including the management and productivity development training from the NDPI in Ghana. As an innovation engineer, I also currently work in Microsoft Teams development, and I'm looking forward to learning more in that division to finally become certified. Joining Engine has been a great experience so far, and I look forward where I know I'm going to develop more as an engineer and make more impact in the organization.
Our vision is to grow to 1,000 people in the next 5 years. Our vision is to become a significant player in the IT industry in Western Africa. We want to replicate what India has done 15, 20 years ago. We want to combine all the other IT service providers in the country, in the Western African region, to form a group of interest that is pushing the idea of we don't want to export commodities. We're not interested in gold. We're not interested in cocoa beans, but we are interested in the human talent of the country.
Ghana's population is now majority being very youthful. Over 60% of the population, young people between the age of 15 and 35. And these young people are also relatively educated. We have over 18% of the population that are graduates, people who have actually passed the university system. And these young people are very much interested in technology. So what we here as Engine to do is to ensure that we give these young people international skills or international standards level of education in terms of skill development, and then connect them with our clients abroad.
Coming to Ghana initially was a big step for us, and we wanted to do it right. Like all the medium to small size companies, there was a requirement as well as from our customer side as well to bring down the costs and to diversify what we were delivering. So we were fortunate enough to meet people like Bernard from Engine and who were able to showcase the capabilities. And then we had to see it with our own eyes. So we came here last year and we met the people. Before coming here, we had already deployed a team of 4 that had been working for us from 6 months. We were continuously monitoring the quality of the resources and what they were delivering and how it was impacting us. So since we got really good results, we decided that, okay, it makes sense to come and visit the country.
The second vision for InGen here is really to be, let's say, a great partner to the ecosystem. So we want to make sure that we position Ghana well globally, so that it's a great way to develop the sector. And by being the driving force of that, we think we can bring some best practices from other countries around the world. We can harness the already good work that's been done by some of the companies here, and together we can make this a very attractive destination for other companies coming here.
So, of course, as the Swiss ambassadors, this makes me thrilled. You know, it's always nice when you see that, you know, Switzerland and Ghana relations are being strengthened. So that's all what our embassy is about, right? It's about strengthening relations between the two countries. So an investment by a Swiss company in Ghana is, of course, something that we rejoice about. But then it's also, it makes me very happy because InGen has already created jobs for young people in the country, and they're planning to create even more. So it also makes me happy for Ghana.
At InGen, currently our target is to recruit and employ about 100 people by the end of the year. And we are looking at accelerating this employment to about 1,000 people in our 5-year strategic plan. With these 1,000 people being employed in the next 5 years, we believe that we will be able to now be well established in Ghana, because we will have a lot of people working for companies all over the world. We will also contribute to the IT skills and the capacity of young Ghanaians, because then we'll have a lot of people who are working as system administrators, data scientists, DevOps, and system support engineers. So these engineers will then contribute a lot more to what we already have here in Ghana.
Hello, my name is Janet Akwa Ahin, a recent graduate in biomedical engineering from Kwame Nkrumah University of Science and Technology. I'm also a participant of the TDIP. Mind telling us a bit about TDIP? Okay, so TDIP is the Tertiary Digital Innovation. And what motivated you to join the Tertiary Digital Innovation program? Okay, so back in school, we all worked on projects, our final year project, and I felt my project idea shouldn't stay on my lecture shelf. It should be worked upon because I felt it can solve a specific problem in Ghana. So I joined the Tertiary Digital Innovations. What benefits have you gained from participating in the TDIP? Okay, personally, I have learned a lot in terms of entrepreneurship. I've been able to do my market research to know my potential customers. I've been trained in terms of communication to be able to pitch to potential investors. I have been able to draw a business plan as well as a roadmap for my startup company.
Is there anything you would like to say to the sponsors and partners of the Tertiary Digital Innovation Program?
Yes, first of all, I'd like to thank our sponsors for organizing such a program for recent graduate to help curb unemployment in Ghana. And I would also like to suggest that they partner with most local manufacturers in Ghana to help us build our products faster and bring it into the market faster.
Thank you so much for your time, engineers, and thank you so much for putting more light in the Tertiary Digital Innovation Program.
Thank you for having me. Bye.
Tell us some more money promo. What's up, you 1 million?
Baba 1 million.
Nana, then meya menye sika bebre.
No, champagne. Osum de sanka pito ne snap. Anu tena me de get ha komfo. Poka tell me.
Fino. Tell us some more money. Tomo. Ubenya 1 million Ghana cedi. Nakwa wa ye wad.
Everyone is trying to win millions in the Telecel More Money promo. Win daily and weekly when you reload your mobile and broadband bundles. You can win up to 30,000 Ghana cedis weekly or the 1 million Ghana cedi grand prize. The more you reload, the better your chances of winning in Telecel More Money promo.
Dial *500# or opt in on the Telecel Play app for free.
1 million.
Telecel, connecting energies. This promo is regulated by the NLA on the Caritas Lottery platform.
Transform your business ideas into success stories with Telecel Business. Choose from a wide range of products and services tailor-made to drive your business. Call 0302-233-4040 or email to business@telecel.com.gh to sign up today. Telecel Business, connecting opportunities, connecting goals, connecting businesses. Telecel, connecting energies.
Hi, my name is Tom Gustinis. I'm the CEO and founder of Fourth IR. It's an artificial intelligence company. We call it applied intelligence because we're looking to not only leverage the technology from an academic perspective and a research perspective, but to put it into use in real-world applications. We came to Ghana about 5 years ago. I came to Ghana as the chairman of a foundation that supports entrepreneurs in developing countries. One of the problems that we were trying to solve is that our main corporate headquarters is in Germany and in Switzerland. And when you look at
All right, hello everyone. A very good afternoon to you all. So we'll be starting very soon. We are trying to get most of the people outside to come inside. So for the meantime, I would want you all to move forward. If there's a seat in front of you, kindly occupy the seat for me, okay? The first 2 rows on this side have been reserved, and then the first rows for the other sections as well. So you can start occupying from the second row going. So please move forward. I beg you, I beg you. Please occupy the empty view. Oh, let's make this quick, I beg. Bosses, please come forward. Oh, no, come forward. So that those who will be coming in won't distract the whole program, you understand? Oh, nah. Please come forward, And just them, everyone, please come forward, I beg you. Oh, please move forward, I'm begging you. Or you want me to kneel down? I beg, please move forward. Oh, those are the back. Is it that you can't hear me or what? Please move forward. Please move forward. Please. Guys, I'm waiting for you to move so that we start to. They said they will start sharing the item from the front, so please. Please move forward. Martin and his people. Oh, it's true. There will be refreshments for you. Please move forward. Oh, guys, if you don't move, we won't start to. I'm you. And please, those outside, if you can hear me, start coming in. Now, just the first row, so you can, yeah. First row. Why is it that you guys don't want to receive the item first or what? It was not sharing in front too. Oh, my senior men at the back. What else should I say? Please move forward. So while we wait for the others to join, I'd want us to do this quick informal section, right? So moving around, asking people some questions, right? You don't know the questions I'm here to ask, so hello, okay. So when I get to you, do justice. Now, why are you scared? I'm coming to you. Okay, so information reaching me is that the attendance sheets will be passed around during the program. So call your friends and then tell them to come, because the signing in will be done while the program goes on. You'll tell a friend to tell a friend to tell a friend that the attendance will be signed here. So yeah, Nat, I'm coming to you. Yeah, I'm coming to you. Why are you here in the first place? Yeah, I want to know why you are here, because I heard some of you are here because Prof. Koa told you to be here. Are you one of? You're only here because Prof. Koa told you to be here. Well, Nat is about to tell you why we are here, so don't worry.
I'm interested in the ideas they are about. I'm interested in the ideas. I'm interested in the ideas they are about to share today. Yeah, that's what.
They can't take item. Okay, so Nat says he's interested in the ideas that are going to be shared over here. Let's move to someone else. Yeah, see, I'm coming away. Hello. Yeah. You were running away when I was calling you. So why did you decide to come? Come here. Because when I was calling you, were running away. So I want to know why you finally decided to come. Yeah, they are listening.
Because people, they say if you don't come, some penalty.
If you don't come, there will be a penalty. And what penalty is that? Also, you didn't want to be deferred. That's why you came. Okay, yeah. Quite laudable. We all don't want to be deferred, right? But you're not seeing the semester top already, so. Yeah, what's your name?
Again, like, I didn't even hear the question. My name is Bismarck.
So Bismarck is afraid to be deferred. Let me move to the other side and speak to two gentlemen. Then we get started right away. Bernard, I'm not coming to you. Prince, how are you doing? So I want to know why you are here. Nah, they want to know why you are here.
Oh. Well, I'm here to learn new things, network, and, have fun.
He's here to learn new things, network, and have fun. So have you started networking already? That's nice. Let me guess one lady and then finish things up. Oh, man, you want to talk? Okay. Yeah, man, I wants to talk, so let's hear from him.
Okay, I'm here for attendance.
Okay, he's also here for attendance. That's